Okay, so we're on part 68 of PAINT5D Sprint, which is not really much of a sprint. We're on number 68. It's Monday. Still Monday. It's on video 136. The last video was 135. So we're 136. That makes sense. GPUView is what we're working on. Monday, 136. Okay, that all looks good. That all checks out. So I'm gonna do like I don't know, a 30-minute break or something. Also, let's change this number, right? So this is stream number 136 now. So let's do done on that. Change that. And yeah, so I gotta do drugs. And then I need to do, let's see, push-ups. Push-ups, I just need to do 40 more. 140 per week, so I'll try to crack those out as well. And so that should be, let's give it like a 20-minute break. Cause I kind of, yeah, let's give it a 20-minute break. That should be enough to do 40 push-ups and take my drugs. So let's go to the break screen. And let's do red timer. Let's do 23 minutes. And I'll be back.
Two, three, four, five, six, seven, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, squats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, weights. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, okay? 20 more of everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 18, 19, 20. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. Squats. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Weights. 1, 2,
Hey,
3, yes, 4,
did we press my code?
no, 5,
Where is it?
6, I don't know, 7, what?
Not press it.
8, I need it. 9,
I can't find
10,
it. Give me your
11, is it 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So 2 sets of 20 makes 40. Yeah, 15 minutes left. I'm gonna see if I can take a quick shower. But first I gotta change my push-ups here. So 140. And 140. And 140. Okay.
Okay. Still got a little bit of time here before break is over. I'm gonna try not to cancel myself on Facebook. Or not. Okay. So we got our push-ups done, so that's cool. because that sucks, and we got it done. We don't know what's going on with this, but we should try to write some test cases for... Sure. We should try to write a test case for what we're doing. And maybe that'll help us a bit. So let's try something where we're being a little bit more... Let's try to be a little bit more extreme. And let's try to target exactly this cell here, right? So we're thinking that it's, that if we want the upper left corner of this cell, right? So we'll try to get the math exact, right? Because we're screwing something up, the mapping isn't working, so there's something we're doing. So, using current use case, let's change this around, because now we're at, like, 136, and it's like, you know... So we're going to write a final test using the current use case, and try to map exactly to the boundaries that we want to map to. So we're saying that... So first of all, let's slug in this thing right here, right? Let's slug this in. And let's do it, like, you know, a few more times, right? So this will be, the first one will be the setup, and the ones that are after that will be the respective corners that I'm trying to target here. And for the setup, we just want to get the proper destination bounds for this cell, this 32 by 32 cell. What are the bounds of it, right? So we're thinking that the bounds of it are, you know, the top corner here is 128 times 0, 1, 2, and 3. 128 times 3. Let's just roll with this math for a second here. So we have like a 128 times 3. We're trying to get that first pixel of the cell we're targeting on the x-axis. So 128 times 3 to get 0, 1, 2, 3 to get over here. And then 0, 1. So to get the first cell, these are 32 by 32 cells. So then we want plus 32 times 1. Okay. And if we do that, we get 416. Okay. Yeah, I know exactly what I expect. So I'm going to put that into the test case and see what the hell is going on here. So the lower bound is on the x is this. Now the lower bound on the y is going to be 128 times 3, but on the y-axis, this cell is right up against the border here, so it should be 32 times 0, right? So just 128 times 3 plus 32 times 0, and that should give us... Yeah, exactly. So I've already written a whole bunch of unit tests for this stuff, a lot of unit tests, so I'm assuming that it already works, and that my math is just wrong. So we're going to narrow down this cell exactly, right? So this is the lower bound right here. So we're talking about this cell right here. Right here. We're trying to figure out where this cell is in terms of the 512 by 512 bitmap. So let me throw in your commentary there. So right, yeah. So there's that saying, right, that a problem well-defined is a problem half-solved, right? Problem well-defined is a problem half-solved. And so we're trying to solve that first half of the problem by very well defining what's going on here. So what we have here is we have a 512 by 512 block of memory. And we're going to divide it into 4 by 4 cells, right? So we're going to divide it into 16 cells total, right? So we're going to slice it 4 times on the x and 4 times on the y. Each one of these cells is exactly 128 pixels by 128 pixels. We're going to be looking at this last cell at the very end, and we're going to subdivide that last cell into more chunks that are 32 by 32 pixels in size. And this is the chunk I'm concerned with. This chunk right here stores all of the variables for the PAINT5D system. Because this is a 32 by 32 chunk, I want to get the first pixel of the chunk, right, the lower bound of the chunk, and then I want to get the last pixel of the chunk. And we've got to make sure that we're not off by 1 at all. So if we've done this correctly, right, if we've already gotten this math correct, then to get the last pixel, we want to add 31. So not 32. We don't want to add 32. We want to add 31 because the 0th index, right, this is the 0th index right here. 416 is the 0th index, so we want to add 31 to get the last index. So let's go in here and let's just do that. Let's go take this 416 and we'll add 31. And we just want to eliminate, like, if we can get this working, then it means that the problem is not in our mapping logic. The problem is somewhere else, right? So if I get this working, the problem is not in the mapping logic. That is my absolutely certain about that. If I use these values and it all works. Now, if it gets really close but it's not quite correct, then either my logic isn't quite correct or this will be insightful, I think. Okay, so these are the upper bounds. And then for the lower bounds, we want to go 0 to 511, right? So 0 to 511. Oh. 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 Okay. I already think I know what it is. I'm trying to take the source viewport I thought was 511 by 511. I don't... No, that should be true. That should be true. But we might want to make sure that's true. We might want to make sure that it's a 512 by 512 viewport, right? 0 to 511, 512 to 512. Not certain about that. But let's just take this, and this is kind of a... This is the setup, right? So this is not really... This one is not meant to do anything. This is just the setup. And then we're going to paste this a whole bunch of times. Well, actually, before we paste it a whole bunch of times, 1, 2, 3, 4. 4 tests, right? So, the test index here, let's steal this. And you want the top left and bottom right corner positions of the 14 squares. I want the... So this cell right here, is a quad tree cell. Well, it's not really a quad tree, right? It's we take this and we subdivide it and we delve into this subsection, and then we take this thing right here and we divide it again, and then we take this cell right here, and this cell is, 32 by 32 pixels. So what I want is this cell right here has pixel locations, right? So I want the upper left corner pixel, the first pixel of this cell, and then I want the last pixel of this cell. So right now we're looking at the kind of the quad tree. We're looking at the quad tree location of the cell, but I don't want the quad tree location of the cell. I want the actual pixel coordinates of this cell, right? Because this cell is just an overlay over a 512 by 512 bitmap. So we're subdividing. We're taking a 512 by 512 bitmap, and we're kind of we're imposing a quad tree structure over a 512 by 512 bitmap, and I'm trying to take the multi-dimensional quad tree location, right? So there's a three-dimensional, there is a, I guess it's a six-dimensional coordinate, right? Because we have a X and Y cell here, and then we have an X and Y cell here. So that's 4 dimensions, right? X and Y and X and Y. And then within here, we want to get the XY here and the XY here. So it's kind of like a 6-dimensional coordinate, right? So we want to collapse that kind of 6-dimensional coordinate into just a normal XY coordinate on the global canvas. But anyways, let's take note of what the actual test cases are here. So this right here is where we're trying to write this stuff. We kind of just pasted this here. And this is now going to be 16, 17, 18, and 19, right? So there's 4 test cases. And the first test case has like a little separator. So let's kind of add a little visual separation here. And let's put this over here, right? So we can know that when we're looking for the test index 16, 17, 18, or 19, it's one of these test cases right here. So let's make sure that we can... Yeah, this is, yeah, this is fractal-ish. This is kind of fractally, but it's not, this isn't for rendering. This is for, data storage. So... I'm trying to, for every single editor, or any system that needs memory in my game. Right now, any system that needs memory always uses a 512 by 512 pixel allocation. So I'm trying to normalize the way I write this game so that every big system, or we should say editor in this case, every editor gets a 512 by 512 block of memory. It does not matter what the editor is. We're always going to try to make sure that the editor's memory is a 512 by 512 allocation of pixels. Now the thing is because we're using a 512 by 512 allocation of pixels for every single editor, sometimes we have to chop and dice up that memory into different layouts. And so this first thing is basically just a subdivision where I don't know what this memory is going to be used for, I don't know what this memory is going to be used for, I don't know what this memory is going to be used for, and I don't know what this memory is going to be used for. But I know what this memory is going to be used for. And this memory right here is going to be used for memory for all of the different editors. So editor 0 memory is here, editor 1's memory is here, editor 2's memory is here, and this is like uniform memory. This is not like tile sets and whatnot. These are like all of the random loose variables that I need for every single editor are going to be allocated in these chunks. So editor 3, editor 4, editor 5, etc. Editor 9, 10, 11, all the way up to 16 different editors. Editors 0 through 15, right? Now if I everything, it's 1D. So this is an index location. So what you're looking at, these numbers here correspond to the editor, but they're also index locations. So this 6 is the index location, and the index location maps to 0, 1, 2, 2, 1. So index 6 is 2, 1, right? So these numbers here are index locations, which, I store, everything is stored, yep, exactly, yeah, so, right, like, all memory is just a flat array, right? We abstract memory into different dimensions, but the way I do it is I always allocate my memory as if it were a flat array, and then after I have a flat array of memory, then I start to add abstractions on top of it with, like, math. So I don't do, like how you do the syntax, like you did, like, some array, width, height thing. You did something like that. I don't do that. I just, use, 1D to 2D math on a... Right. So I don't do any like language features like that to... I try to keep the code kind of simple, so I don't use any language features like that. I always, as far as the language kind of knows, it's just a one-dimensional array, and then I treat it as a two-dimensional array with, the proper index to XY math. That's like just the way I do it everywhere. That's just the way I do it. Yeah, multi-dimensional arrays aren't very flexible, yeah. So, let's give this a run. So before we even try this, we know that we have 19 indexes now. If we have 19 indexes, that means we have 20 tests, right? So If we look at the number of tests, 16, we added 4 tests. That checks out, right? We have 20 tests. Excellent. So let's just give this a run and see if... let's close this. Let's just give this a run and see if we can get this working. And if it works, we're going to add the... We're going to flesh out those last 4 test cases. And if that works, then we have more certainty of what code is correct and more certainty of what code is wrong. And we'll just kind of go from there. So let's just cross our fingers here. Okay, so test number 16 is failing us. So let's go look at that. Let's put this over here because it's on the left. And test number 16 is this first test. And okay, we're getting oh, this is 0, 0, so therefore the output would be 0, 0, right? But instead we're getting this because it's 416, 384. Yeah, actually the test case, the expected value is actually correct, right? Because we're mapping from here to over here, and of course, if we're doing that, then that would be what I would expect. Okay, so we'll just throw that in. That is actually correct. That's just me being wrong. I'm wrong. So the test failed, but not because the code was right or was wrong. The test failed because I wrote the test wrong. So let's put that back in and make sure the tests pass, and then we'll kind of like change things around and figure out some more stuff here. Okay, cool. So that passed. Okay, so now what we're going to do is... Oh, actually, I want one more thing here. So we're going to change that up to a 21 here. Okay, let's make sure that still works. Let's make sure we don't seg fault or anything. And then also I need to check my calendar here. So at 7 p.m. on the 16th, which is tomorrow, I have to go to the shop. I'll probably be pretty tired by then, won't I? Okay. Okay, so that's still going. That's cool. Okay, cool. So now we're gonna steal this. We're gonna steal all this. And we're gonna try to go tests. We want to go top left, top right, bottom right, and bottom left, right? So now, actually, do I have shortcuts for what those abbreviations mean? Because that's kind of useful, and that's what I use them for. So TL means. Do we have an abbreviation? Nope. How about TL means? Like TL means. Nope. What about TL means, or TL... Well, I'm pretty sure that if I don't have those, I don't have these, but... And how about TL means, like that? Nope. And how about lowercase TL means? Well, of course, if it's spelled like that, of course we're not... Okay, so if I type this, TL stands for top left. Let's just call it top left. I abbreviate enough where I know exactly what that means. And then let's get a FARC template here. FARC template. And let's fill this out for a second. Let's steal this. Let's paste it right here. And let's find top left, and let's replace it with top right, bottom left, and bottom right. So we're going in scanline order. Scanline order. So over to the right, from the top left over to the right, and then once we go as far right as we can, we go down, and we kind of like reset over all the way to the left, and then bottom right. So bottom left, bottom right. Okay, so let's take this and steal it, and just go FARC, find and replace clone. And now obviously we have to change the definitions, but we saved ourselves some typing here. So this is going to be top right. This is going to be bottom left, and this is going to be bottom right. Right, so I use the abbreviation for top and bottom and right and left like this so much that I do not need to spell it out You can kind of tell from the abbreviation. And also, I just use that abbreviation so much that that's fine. I also use these abbreviations so much that I already know what they mean, but I just want to canonicalize it. Okay, so now that we have that, let's, the test index are now going to be 16, 17, 18, 19, and 20. So that is kind of a lot. So what we're going to do here is we're going to say test index equals 16 here. And we're going to say test index here. Test index equals... And then just slide this over here. Just so that... Because that's getting to be a little bit... it's getting to be a little bit too much in terms of test, right? So when you cluster things, usually after a grouping of 4... it depends on your, like, your raw... When we talk about, like, brain processing speed, like, for people who are, like, super smart, they can look at groupings of more than 4, and they can tell what they're looking at. But for, like, people of, like, average intelligence, you know, it's, like, groupings of, like, 3 and 4, right? After you get past that, the groupings start to get confusing, right? Like, if I like, give you a string of zeros right here, like, you can't immediately glance at that and be like, oh, I know exactly how much is here, right? But with 3 you can, with 4 you can, and then after 4, it really depends on your I don't want to say IQ, because it's not really IQ, it's more like your brain processing speed. So IQ kind of encompasses other things. Like, IQ encompasses, like, if you read a lot and you just study a lot, right, your IQ will go up. But we're not talking about that kind of IQ. We're talking about raw processing power, right? So some people could probably look at that and understand that that's exactly 5. Then some people who are even smarter could probably look at that and see that that's exactly 6. I'm pretty average in terms of my processing speeds, so I really only... This is the most I can personally understand. So, I mean, I guess it's kind of good that I'm not, like, super smart, because I want to, like, write an engine that other people can understand, right? So, if there were a whole bunch of very complicated things that were kind of, like, that I kind of looked at them and I'm like, oh, of course, then I would make something that would be out of touch with everybody, right? So, like, so I want to make something awesome, but I also want to make something that other people can understand. So, I think that the more intelligent you are, the harder it can be to communicate with people, right? Because you take a whole bunch of things for granted. Okay, so we have these coordinates here. Let's start kind of remapping some stuff. So this is... So we always want to keep this same range here. We're always going to keep this same range. But we're going to try to remap. So this would be the top left. We already kind of did the top left, right? This is the top left, right? Yeah, this is already the top left. We can just duplicate this. This is the top left. I don't care if we duplicate it. Fine, whatever. So then the top right, what we want to remap is we want to take, okay, well, it's going to be 511 on the X and 0 on the Y, right? That's going to get us the top right. And all these numbers, we can copy over all these numbers, right? So let's copy these numbers. So all of these numbers are going to be the same too, right? All these destination, right? So this is the source rectangle, this is the destination rectangle, and we're just trying to get end up mapping to the different corners of the destination rectangle. So if we go all the way over, we're going to expect, instead of so these are the minimum bounds, these are the maximum bounds, right? So we're going to expect 447 on the X, right? So 447 on the X, but still this 384 here, right? And if we do this, if we do a 511 here, right? So let's copy this over. Then on the upper bound on the Y, so X upper bound, Y upper bound, we're going to expect, 415, okay? And if we do a 511, right? So, hold on. Go over on the X. Go down. Okay, just making sure. Just making sure. So now if we go all the way over, it's going to be nothing but upper bounds. Right? Because this is an inclusive rectangle. Everything's inclusive. Okay. So we're going to throw that in there. If this test passes, then I know the problem's somewhere else. I'm like absolutely I'm absolutely convinced the problem is somewhere else. And what we might want to do is actually hard code these values into the editor or into the memory viewer. Okay, so those all passed. Those all passed. So we might want to do a little sanity check here. So 415, let's throw another 5 on there, right? Let's throw another 5 on there. Make absolutely sure that last test is running, right? So make sure we can crash the system if we give it the wrong value, and then we'll look for other problems, I guess. But it looks so far that this remapping code looks good to me. So okay, this fails, right? Because we added that extra 5 there, which is what I expected. So I just want sanity of mind that all of the tests are running, right? We know all the tests are running. And so we tested our conception of what's supposed to happen, and the test passed, right? Okay, so if the test passes, then the reason for why we're not seeing exactly what we want to see here, right? So I'm expecting to see a little pixel of color here, like 4 gigantic pixels here, and then 4 gigantic pixels here, and then 4 gigantic pixels here, 4 gigantic pixels here, right? I want to get those bounds mapped to the screen, right? So this is, I'm zooming in, that 512 by 512 texture, I'm zooming in on it, right? I'm zooming in on a 32 by 32 section, right? So that's what I'm doing. I'm doing like a camera zoom, and for some reason, that zoom logic is not working. And the zoom logic is very hard-coded. So let's go look at the so PAINT5D fragment shader. Let's close this. This fragment shader. Let's put this fragment shader code over here. Okay. So let's go down to where we're doing this nonsense, and let's the first thing I want to do is I want to write an assert. And I want to assert that, because now we have these bounds. We have these bounds that we hand calculated, right? And that's what this is supposed to be, right? So there's the possibility that we didn't do these calculations correctly. So let's do some asserts and make sure that that's correct. So assert that x0, sorry. We want to assert that the x0 is this, and let's kind of duplicate this a few times. So we want to go for the lower bounds and then the upper bounds. So xy, xy, and the upper bounds. And usually I do things, you know, general to specific, but it just makes more sense when we cluster by upper and lower bounds here. And so this is the y lower bound. So here's the y lower bound. Here's the x upper bound. And here's the y upper bound. So if any of this fails, then we know that our math here is wrong, right? So that's the goal here. So let's just say, you know, let's make a @vid IID 0136, and the time is 53:23. Keep that conspiracy going. And let's say paired comment 2021 GPU view asserts. So make a little paired commentary. I'm gonna call it parcom for paired comment, just because I'm running out of room here. 1, 2, 3, 4. Yeah, I was running out of room, so I'm just gonna call it this. And then I'm gonna take this exact timestamp here, and I'm just gonna throw it over here, right? So I'm gonna say that this is a paired comment. You know, then we might want to say like paired comment. Okay. And then over here, I want to identify this as a paired comment, right? So the little @paired comment, then let's make sure that we have that kind of thing in here, right? So let's make sure that if we look in our hashtag documentation, that we have documented what a paired comment is, or if we have not. So we don't. So let's go over here and let's kind of document that. So @paired comment or @paired. There's the possibility that I already wrote this. So let's make sure that that's not somewhere. So let's go look for that. Nope. Okay, cool. So we're just going to document what I mean by a paired comment, which should be kind of obvious by what I did, right? Boop, 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 boo. Okay. A comment that is supposed to be paired with another comment in another block of code somewhere. This other block of code may be in a separate file, or it may be in the same file. But the point is that there is another block of code somewhere, and you really need to look at that other block of code to fully understand the comment you are looking at. Right? So let's make a little note of this. So we're at vid IID, and it's 136. And the time is 56. 42, because we want to be cool. Okay. So that's what a paired comment is. So I thought that I would have put it somewhere else. Also, if we say something like parcom, or if we say, you know, parcom, if we say something like parcom, or something like parcom, if we say any of these things, we're going to mean, that's going to be the same kind of deal. Same deal, right? So any of these things means a paired comment. Okay, so now that we have that out of the way, do we need to keep this open? I'm going to say, nope, let's kind of clean up what we're doing here. Yeah, so let's give this a run. Let's give this a run and see if it crashes or not, right? So, now, yeah, okay, let's roll. Let's do it. Let's do this. Let's do this. Okay. All right. I mean, oh wait. Well, the asserts passed. Okay, the asserts passed. Well, okay. So the asserts passed. The tests pass. But yet, when I look at this, that doesn't look correct. So, what's going on? So that's kind of crazy. And this is like right on that edge, so... Okay, well, first of all, let's do a sanity check here. This viewport right here, is this viewport... Are we looking at 512 by 512 here? Right? I don't know what this is going to open, so I'm going to put this on a different screen really quick. And we're going to call this sanity check. Okay, sanity check, and let's close this. So I still don't know. Close the program. So our tests are passing, our asserts are passing, like everything is telling us, hey, you got this right. But yet, for some reason, we're failing here. So let's go open up paint.net. And... desktop, delete me, Sanity check. Okay, so let's go look at this sanity check and make sure that there's not like a... Right, if we were like... We'd have to be off by many pixels, right? So we have to be like 32 pixels off for this to be not looking correct. But, I mean, this looks about correct. So what we're going to do is we're just going to zoom in here and we're going to select some stuff here. So we can already see that some of this doesn't look quite right. We're like this looks like off by 1 here, right? So off by 1 there. So that looks bad. It's off by 1 on there, right? So we have some issues here where things don't look pixel perfect. So we're gonna steal this. Then we're gonna go File New and see, like, what do we have? So we got... Yeah, that would be a thing, right? Okay, so we got 511 on the X, but height... Look at that height. That height is... So first thing we gotta do is just expand our viewport. Our viewport is not 512. So I think what I did was when I did the native window code, I probably set the window is like 512 high, but that's not the client area, right? So the window is probably measured 512 in, I forgot what the other, I think you just call it the non-client area, but the entire window, including the borders and the margins and whatever the heck you want to call it, the entire window is probably 512, but the client area is not. And so we're not actually, so I thought I was looking at a 512 by 512 section on the screen. I'm not. That's not what I'm looking at. So of course we can't see this pixel down here because we're not looking at that, right? Now this still looks wrong on this thing still looks wrong, right? We're still off by 1 here. So I have to figure out what the hell is going on there. But now that we realize that, let's Yep, client area, yes, you are correct, yes. Client area does not include borders. Yes, correct, yes. So I have done enough like Win32 code that I kind of know that. But I don't know what you call the non-client area, right? Like there's no word for it that I know of, right? It's just called, you know, I don't think there is a word for non-client area. So is there a word for non-client area, right? Because I don't think there is. Is it the client area and then the window rect? I think the window rect, I think in MSD and documentation, I think that the whole window, when they're talking about the title bar and all that other nonsense, is the window rect, and then the client area is obviously where you have your like OpenGL context and stuff. Yeah, but yeah, it's not something. I'm not gonna worry about it right now. I'm just gonna. Okay. Yes, get window rect and get client rect. Yes, get window rect and get client rect. Yeah, that's exactly what I'm talking about. Exactly what I'm talking about. Yeah, because really, you only really need the last one, right? Like, you don't really want to be messing around with the window rect, right? Like, why? I mean, maybe there's some type of legitimate use, but honestly, like, what are you doing if you're doing that? Like, I feel like you must be writing malware or something if you want to get the entire window wrecked. And you know, but maybe I don't know what I'm talking about. But then you also have to write shellcode and all that kind of stuff. Okay, so we know that this just needs to be. If we pop this up here, oh hey, look at that. We're closer here. We're closer. My calculations are off by 1. Okay, you know what? we're very close. We're very close, but we're off by 1 pixel. This is what I'm talking about. This is what I'm talking about when I say, like, you know, it's basic geometry. We're doing very trivial geometry, and the geometry is, like, it's really easy stuff. It's really easy stuff until it's like, oh yeah, do this formula, but be exactly correct. Don't be off by 1, right? Once you have to be, when you take mathematics, like normal geometry, it's pretty easy. But then when you turn it into discrete mathematics, where like everything has to be pixel perfect, right? Then you have huge problems, right? And then it gets even worse because, yeah, sure, this is 1 pixel, but what if this wasn't 1 pixel? What if this was like 1 gigantic block of memory and you're off by an entire memory block, right? So like, off by 1s could get you like really, right? They could really screw you up, right? Everything has to be perfect, right? It's code. Everything, it has to be perfect. If it's not perfect, it's not going to run, right? Unless it's JavaScript, and then you can just do a whole bunch of weird BS, and it'll still run no matter what. Okay, so I see what's going on here, and I could just add 1 to the Rex, and that would fix it, but that wouldn't be... It would fix it, but it wouldn't be... We gotta understand, we can't just, like, be like, oh, it's off by 1, just add 1, right? Because we don't just want to be like, oh, it's off by 1, oh, well, just add 1, right? That's... No, because then, we don't know what we're doing. We're just trying to, like, shove in a magic number and whatnot. So there's another assert we can do, right? So we can assert that 32 equals... And we can take the x1 minus the x0, right? So this is an inclusive rectangle. So we want to add 1, right? Because it's an inclusive rectangle. And that assert should check out, right? So we want to do a lot of these asserts. So, well, actually, no, we only need 2 of them. What am I doing here? So then the y, so the upper bound on the y, and then the lower bound on the y, right? So let's say this is 0 and this is 0, right? Well, 0 minus 0 is 0, but the width of a inclusive rectangle that's selecting a single pixel would be 1, and that's why we have a plus 1 over here. Because these rectangles are inclusive, right? So like in Win32 code, you don't use an inclusive rectangle. Like the rectangle does not include the last coordinate, and I just find that confusing. I know why they do it, because it makes it very convenient for cutting and pasting when you're cutting and pasting based on the top left corner of a graphic. So I get why they do that, but I hate that. I always like to do my math with like inclusive ranges. So let's make sure this assert checks out. Like maybe we have, maybe our math is off by 1 and we've done everything, but we just don't know what we're doing, right? So let's see if this assert fails. So I think this assert is going to fail, and if it doesn't, then I don't know, man. I don't know. And it doesn't fail. It doesn't fail. Okay. It didn't fail. It just worked. Okay, hold on though. Because... No, it's in here. Okay, whoa. Hold on. This assert, these asserts are not actually getting ran, right? Because we don't run these asserts in the GLSL code. We run these asserts when it's as C99 code. And we're never running it as C99 code. So this function here is called function main. Okay, I see, okay. So this thing right here, is not going to be called GPU wire. It's going to be called GPU view. And then we can hackishly test this though, right? So what we're going to do here is in this unit test, we're just going to call this function once. And figure out what arguments it takes. So let's look at function main. It takes a float vec4. Yeah, it takes like a float vec4. Okay. So, float vec4, float vec4. So we have to call it at least once to trigger those asserts, right? Because those asserts we cannot assert in GLSL code. So the asserts are only caught when it's ran as C99 code. And right now, the compiler errors we're getting when we try to run this they're compile time errors, right? But asserts are runtime errors. So if we want to get that runtime error, we got to call this function at least once. So first of all, this is not correct. Okay. So float vec4, fv4, okay, and we can just zero initialize it. We don't really care what's inside of it, and we can make a note of this. We can make a note of this at vid iid 0136, and the time is 1 hour 10 minutes, and let's do 32 seconds because we like powers of 2. Okay. Call the fragment shader main from CPU side once, so that C99 asserts for main function are checked at least once. So we're not actually, yeah, we're just going to try to invoke those asserts, right? So now that we have this... Oh, hey, how's it going? Oh, yeah, so I was like... I was not, like, paying attention, and I was like... So, yeah, I am, So Anime Dude has been working on some little, what do you call it, like, little games? Little in the sense that they're kind of, they're small games. I don't want to be, like, disparaging, but, like, you're trying to churn, what I see you doing, it looks like you're trying to churn out, like, a lot of games really fast, so you can get used to doing the whole process from start to finish. That's kind of what I saw from what you're showing me. But yeah, they have some interesting links I was looking at. And also... do you go... So, also, I was wondering about those MIT URLs. Do you attend MIT, or, yeah, simulators, right? You could call it that, right? Like, I went to DigiPen, and I didn't do the programming degree, but the, video game programmers, their degree was called, Real-Time Interactive Simulation. Right, because if you think about a game, right, you got physics, you got sound, you got collision, you have rendering, you have physically based rendering, right? So rendering engine is a, yeah, you use scratch.mit.edu. Yeah, is that like a thing that anyone can use, or, yeah, because I know that's kind of like what you've been up to. But, yeah, so this thing right here, like, now it said Scratch, so is this the, kind of, like, thing where you kind of, like, plug stuff together? Because I think I know what Scratch is, right? Like, which is, like, a good learning tool, but, yeah, I know what this kind of stuff is, yeah. So, have you ever used, did MIT... Well, maybe that's made by MIT, right? Because Scratch.MIT, maybe that's an MIT project. Used, yeah, so, like, Unreal has, like, a graph-type language. And, so when you're doing, like, when you're trying to program using, like, a visual language, the nice thing about it is you can't make syntax errors, right? Like you just pipe one thing into another thing. And so if you think about a visual language, it's very functional, right? Like when you think of a functional language, you gotta focus more than that, man. Like, yeah, like I mean, it's not gonna be easy to learn at first. Yeah, how old are you, by the way? Like, I have no clue how old are you? I mean, you don't have to answer that if you don't want to answer that, that's fine. Because I know, I'm not an interviewer, I'm not like a job interviewer, so technically it's a legal question, but I still try to, like, you know, not be... But, like, when I was in high school, actually, no, this is middle school. When I was in middle school, my dad was a programmer. And, you did good. JS should not be used. JS is kind of weird. Yeah, that's fine, that's fine. You don't have to. You don't have to give away that information. But, like, when I was in high school... Was it high school or middle school? No, it was middle school when I first tried... Okay, so, yeah, it was middle school. I tried to make, like, a like, decoding and coding kind of program. And, my dad helped me make this thing in, like, Visual Basic, right? So, like a thing where you'd enter, like, you take some text and it would, like, encrypt it into, like, use kind of like a cipher. Not like a Roman, like, shifting cipher. I forgot what they call that shift cipher. The Roman shifting cipher, where you just shift the alphabet over. But yeah, so my dad helped me make, like, a little encoding program where I could just take text and kind of encrypt it into, so it's still like ASCII, it was ASCII to ASCII, right? And the first thing I wanted to do is like, oh, you know what? When the CIA is trying to decrypt messages, one of the ways the CIA tries to decrypt messages is they use frequency analysis, right? So I'm like, hey, let's make a thing where, like, A can either be, you know, it could be 1, 2, 3, or it could be 2, 3, 4, or it could be like this, right? So let's make a code where the A could be this, this, or this. So I was like, hey, let's make a little code where we can thwart frequency analysis of the message, because the A can turn into this, this, or this. So there's more, so it's not a one-to-one encryption, because it could be any one of these things, right? But then backwards, 1, 2, 3, 2, 3, 4, and 5, 4, 3, they all map to A. So I was like, hey, let's do that, and then that'd be really cool, because I think then people wouldn't be able to break it, right? Because if we're taking Roman letters, right, then people could just kind of swap out the symbols for different letters and guess and check until they can kind of break it, and that would be really easy to break. So I'm like, hey, let's try to thwart that kind of frequency analysis. And so my dad helped me write this thing, and I didn't really understand the switch statements, I didn't really get it, and it wasn't until high school when I did like a Visual Basic class. No, it wasn't a Visual Basic, it was Q Basic. I did Q Basic in high school. And then I just went off the rails with code, like, because I was like, oh, QBasic, this is fun stuff. Okay, I get it, and it's really easy to get graphics up on screen in QBasic. And so I made, like, 3D Pong and whatnot. And that was fun stuff. But, you know, I had to actually have a class where I had, like, a teacher, right? And then once I had a teacher to kind of show me how to do it, I could learn on my own, but before that, I just didn't know where to go. I didn't know where to start, and getting started with that kind of stuff can be very difficult. So, but once you get started, it's pretty easy to keep on going on your own. But breaking through the walls is kind of difficult, right? Because like, there's a lot of things you have to know, right? Like to do some JavaScript. Like for me, right, I'd write a HTML page, I'd make a .htm page, I'd make a .js file, then I'd have to use the correct script tags to include that, and then, you know, I'd probably put it in a Git repo, so I'd use some Git on the command line, and then I'd go push it up to GitHub and do all that craziness. Maybe I'd throw it up on Heroku, right? So there's like a ton of stuff just to get something working, right? So like, people can say, oh, it's just a hello world, but there's a whole, like, there's a whole environment around code, right? So it's not just the code, it's the environment, and so it can be very difficult to get started. And so, like, I do think that JavaScript is a good language to start out with, just because it's the easiest one to get started with. It's a weird language, though, so there's some weird things that are, like, really screw you up, like function hoisting, prototypical inheritance, what else? Function hoisting, prototypical inheritance. What else is weird? There's a whole bunch of, like, you know, we can add strings, and you can do things in JavaScript, like you can do this, like now you can do this in JavaScript where you do not, and then it turns the variable into a Boolean, and that's weird stuff. Then there's like there's just a whole bunch of like weird things in JavaScript. Your last example is called homophonic substitution cipher. Okay, I'm gonna go look that up for a second. Homo as in same, as in one-to-one. Oh, actually, hold on. Let me go back here. Oh, yep, that's exactly, yep, you got it, you nailed it. Yep, you are correct. Okay, let me throw that in there. So it's like, sometimes, like, big words, like, make you sound smarter than you are, right? Because, like, yeah, I did that when I was in, like, middle school. But if you call it homophonic substitution cipher, you sound like you're a genius, right? But it's really not that complicated, right? Okay. So I'm gonna put that in my notes. And I'll also take that. Yeah, I had a, so not to rant too much, but, okay. So I graduated in the head pads. So in my, in high school, I graduated in the top 10 of my class. I probably would have got, like, I hate English. I hate English class, so, you know, if I wasn't forced to take English class my last year of high school, I probably would have came in first or second, but, English class, man, hate that. But anyways, one of the other top 10 people, in high school was one of my lab partners. And they, like, science was my favorite class. Science is one of my favorite classes. And I took, like, advanced biology. I had this one lab partner that just always kind of annoyed the hell out of me because she would always try to use, like, the biggest words to describe, like, what's going on. And I'm like, come on, no. Let's use the smallest words possible to describe the problem, right? So we don't want, right, you don't want any more... no more detail than what is necessary to describe what's going on. Like, if something needs a quote-unquote big word because it's just there's no other way to explain it, then okay, sure. But, I don't know, I just feel like it's kind of, I don't know, I feel like it's, like, weird, pretentious, and stuck up to just, like, try to throw out big words when you're, but you have to use the academic lingo, yeah, so, yeah, just screw that. Right? Like, sometimes some type of academic word might be the correct situation, but if there's a non-academic word to accurately describe what you're doing, then use the non-academic word so people can understand what the hell you're talking about, right? So, like, you know, yeah, just, annoys me. So, I don't know. I mean, blah, blah. It's like, It's like one of the, and you know what, I get it though, like, and maybe I shouldn't be so judgmental because I definitely have, people who have disdain for me because, like, I'll talk in a way where, they might think that I'm trying to sound smart, so maybe I shouldn't be so harsh with my criticism because I know people criticize me the same way. But yeah, I don't know. It annoys me. It's not like I'll say anything. Like, it annoys me, but I'm not gonna say anything because it's like it's not worth the fight, and it's not worth, like, I'm not gonna trample someone's feelings because they're trying to be smart. Like, okay, yeah, that's fine, but blah, right? But I think a lot of, like, the way you talk has a lot to do with, like, you're kind of signaling your group allegiance when you talk, right? So so if you do academic lingo, you're trying to say that, oh, you have group allegiance to academia, right? And I just have group allegiance to whatever is factually correct, right? I don't really care. But anyways, let's try not to get ourselves in any trouble here. Let's put this over here. Okay. So yeah, we're just gonna run this main function with a float vec4. And we just run it once, and it's going to be a little hack to get some of these asserts to check out what's going on. And we have to define float vec4 over here. So I don't even know if we have a float vec4. Hopefully we do. We probably do. So define fv4 float vec4 as a struct AAC 2020. Poly-OGL is the OpenGL polyfill, so polyfills OpenGL. OGL for OpenGL. And then we're going to say FV4 for floatVec4, right? So these things match right here, right? It matches up, right? Okay. So I know some people would, like, do a type def, but I'm like, you know what? Type defs are going to be global, right? Like, a type def is global. I don't want to, like, I do not want to clutter up my code with a whole bunch of type defs because those type defs are going to accumulate and accumulate for years and years and years and years. And it's just going to hit this, like, super critical, unmaintainable mass at some point if we're just adding type defs after type defs after type defs every single day. So that is kind of why I do these defines, right? So that is why I'm using a define rather than a type def. Like, if anyone was wondering, like, why the heck I write my code this way, you know, that's why. And that's not a float vec 2, that's a float vec 4. Float vec 4, yeah, float vec 4, up here. Yes, okay, cool. So yeah, let's give it a run and see if we start to just get things crashing, because we never actually ran it. And yeah, this will be interesting. Maybe we're gonna see something. Fingers crossed that this does, well, I mean, the best case scenario really is that it does blow up, because we're trying to figure out where things are going wrong, and our asserts are kind of our best kind of guess as to what's going wrong. So the fact that the asserts did not fail, one more thing we want to try, right? So we tried that, nothing crashed. Let's make absolutely sure that assert is getting triggered. So over here, this assert here, our asserts, where are you here? So these asserts here, let's just assert that, let's assert that 1 is equal to 0, right? So obviously not true. But let's just have a sanity check, make sure that, right? Okay, we want a sanity check. We want a sanity check, make absolutely sure that this assert is being called, right? So if we don't get a runtime failure, then I don't know what the hell we're doing wrong. So let's just try to get this rolling here. But yeah, also, Anime Dude, if you want to, like, learn some JavaScript or maybe a different language, like, if there's a certain language that you are interested in, as long as it's not a language I completely hate, you know, I can try to teach you on stream sometime. Like, give you, like, a little demo project, and I can, like, share the code with you on Pastebin and show you all the things to download and all that good stuff. Like on one of my less productive days, where I'm not, like, feeling like writing this code, where, like, I don't want to work on my engine, we could pick out a day, and I could kind of get you started Ideally, I would probably like to get you started with JavaScript. Because it looks like you have some cool ideas. Like, I've seen your ideas. You got some cool ideas, and I think you could go a lot further if you start using some JavaScript and then kind of like sprawl out from there. So I've taught plenty of people on stream how to do some things, and I'm pretty patient, by the way. I'm a pretty patient person. Okay, so this okay, so the assertion fail. Okay, so our sanity check is working, right? So sanity check passes. This assertion is getting triggered. So that means all these assumptions here, they're checking out. So this max is 512 minus 1, 0, 0. Inclusive ranges. This is a global coordinate. GX and GY. Ooh, it's a textile fetch. I'm at a loss here. I have no clue. I have no clue why it's off by 1 like that. Shaking my head here. I should message. I don't even know if, let's see. Should probably message Anime Guy just in case they didn't see that. I'm gonna go message them really quick just in case they didn't hear me. To learn. Okay, just throwing them in there. I just sent them a message just in case. Close that, cancel. Okay, so I am kind of lost here. I'm like, what WTF? I don't know what's going on. So Yuki, then we're gonna go over to here. Why is that off by 1? Because if we open this up, everything is off by 1. Okay, I am. Well, actually, we have the sanity. Okay, let's steal this. Let's steal this for a second. We're gonna save this as sanity check 2. And we're just gonna. I don't know what's going on. So we're going to open up sanity check number 2. And we're gonna give it a little closer look here. So we already know that there's some things that are kind of annoying here where, like, things are off by 1 pixel. Let's take this. Well, actually, no, let's not. Okay, let's actually zoom in here for a second and select all this good stuff. So let's select this. Okay, so we're expecting that if we select this, we're going to get a 512 by 512. And we get a 511 on the X, 512. That's close enough to where I'm not too worried about it. And oh yeah, this thing. What about this? Made the. Oh really? You. All right. Nice. Yeah, that's exactly. Yep, that's exactly. Yeah. It looks like you did this with lines. Or no. I mean that's. Oh no. I think it's lines because it's when you zoom in with a internet browser, right? It does this stupid anti-aliasing stuff. But yeah, no, that looks exactly right. Yeah. Oh, hold on. I don't know, we'll check it out later. We'll load it into the program maybe sometime. And see what we get. RBS fractal lines. I'm just putting that in my notes. Okay, so what we're going to do here is, because we're kind of like stuck here, we're kind of grasping at straws. So we're going to take this, first of all, and copy it. File new. Okay, first of all, the first problem I'm seeing, this is 33 by 33. So if it's 16 by 16 cells and we're losing 1 pixel at a time, and it's 16 by 16 cells, then we're going to eventually be off by exactly, yeah. So this graphic is off by 1 pixel. And if this graphic is off by 1 pixel, and we have 16 of them, then we're going to be off by 16 pixels. And I bet this is about 16 by 16 pixels, right? So if we copy this, file new, so yeah, 16, 17, right? So something about this is off by 1, right? We can tell that this is off by 1 because we got this black here, and then when we look at this, when we actually select this colored region, we're not getting what we expect, right? We're getting, it's not mapping how we expected, and I don't know. Yeah, 33 by 33. We expect it only to be 32 by 32, and yet this is bigger than it should be. So the question is, oh, hold on. No. Okay, we know we're off by 1. We're off by 1. So I thought that we were off by 1 in our mapping calculations, but it seems to be like there's a compound off by 1 where it just coincidentally lines up here. And so this looks like one type of mistake in my math, but it's actually some other mistake that has to do with some type of compoundingness, right? Because if this is 1 pixel too big and we stamp another one, 1 pixel too big, 1 pixel too big, 1 pixel too big, and we do that 16 times, then we use up 16 pixels, and this is exactly 16 by 16 pixels here. So there's some type of cumulative compounding error going on. There's a cumulative compounding error, and I don't know what it is. So I don't get it. I really don't get what I'm doing wrong. Is the texel fetch wrong? So we take the fragment coordinate, and we minus 0.5 to get a discrete pixel coordinate. The y is a little bit trickier, but we know it's going wrong on the x and the y, so we can't just rule that out, because even if the y was the problem, we can see that we're calculating this pretty correctly, right? So we have a fragment coordinate. Now, hold on. Greater than or equal to 512 minus 1. Okay, well, the first thing here is that this is wrong, right? So the last valid pixel is 511, right? So this is 511, greater than or equal to 511, or this is greater than or equal to 511. Then we're going to do this. So this is off by 1. So if we want to write this in a more correct way, yeah, well, let's just do this, right? So if it's out of bounds, right? So out of bounds. So first of all, there's one source of off by 1. That's probably our off by 1 pixel. I don't believe that's going to solve everything, right? That's one little mistake. But we never know. So let's kind of look at that, see what we fixed. And then I don't know, man. I did not expect us to be spending more than 9 hours on this. I did not expect to be taking any more than 3 hours. Like, I feel like, I don't know, I didn't... the more I work on this, the stupider I feel sometimes. Just because, like, I spend so much time on something I think is completely trivial. Let's just do, let's go over here, let's do the U key, and then let's go over to here, and look at this, and now... Okay. What the heck? Let's snip this for a second. Snip. Okay, let's look at this. I don't know what's going on here, but it's different. Okay, so if we zoom in on this for a second. Okay, so the blue look just looks off by 1 when I'm looking at it because, right, blue and red, right, they are, when you look at an actual pixel, like if you ever took a microscope up to a pixel on the screen, you know that the red, green, and blue components of the LED are physically in different locations, right? They're not overlapping. And so sometimes when you have something that's pure red, pure green, pure blue, they look slightly shifted to different locations. And so that's what I was looking at. So now what I'm noticing is I thought I saw, yeah, I see a little sliver. I see a little sliver right here. I don't get it. I don't understand what I'm doing wrong here. I did all the math, and the math worked out, and then still blows up in my face. So the other thought is the texel fetch isn't correct. But if the texel fetch wasn't correct, then why would we have a little sliver here, right? Why would we even have a little sliver? I don't know. I don't know what I'm doing wrong here. I don't know what I'm doing wrong. I do not know what I'm doing wrong. What is this? Make U32. IVEC2. Global. Mm-hmm. Is my texel fetch off? Is my texel fetch not working? Perhaps my texel fetch is not correct. int vec2 gx and gy. And gx and gy, those are integers, right? Yeah. Int vec. My thought is maybe my textile fetch is wrong. Maybe the textile fetch is wrong. I don't know. I don't get it. I do not get it right now. I do not understand. Textile fetch would be... We've looked at everything else. I mean, the textile fetch is kind of like suspect right now. Let's go look at the textile fetch for a second and see what that kind of evaluates to and see if maybe there's something going on here. So textile fetch, right? So it's just textile fetch, right? Let's go look up textile fetch for a second and see how that's supposed to work. No, I mean, textile fetch... I think I'm using that correctly. TF for textile fetch when we're running as GLSL code, right? Textile fetch. Okay. The X and the Y to make it int vec2. Perhaps the making of it int vec2 is wrong, no? Because I vec2 would be... Let's make sure that's correct. So I vec2, right, int vec2 to get a textile chord. Otherwise, make int vec2. What's the condition here? If it's in bounds, right? So if either it's out of bounds in the X or out of bounds in the Y, if either of those are true, we're going over here, right? I'm off by 1. I don't know what's going on. I don't know what's going on. My tests seem to be working fine. It seems to be the rendering that's not working. I don't know, man. I don't know what's going on. We're going to... The max inclusive coordinate, 512 minus 1, right? That makes sense. But it seems as we're mapping it, as we're going through every single coordinate, everything is kind of slightly off. If everything were slightly off... Well, it's not the destination. The destination isn't off because... Huh. x1 minus x0 plus 1 equal to 32. Those assertion works. The assertion on the y, that also works. So we're absolutely certain that this lower bounds range works. And then we do this upper bounds range, sorry, the upper bound range, we're certain that works. This max here is just, you know, 512 minus 1, so the maximum coordinate is this, like, 511, and we're sure that works, because 0 to 511 is the correct region. I don't know what's wrong. I don't know what's wrong, and it's kind of infuriating. I don't know what I'm doing wrong. But it doesn't look correct. Okay, so here's what we're gonna do. I have no clue what's wrong. I had a to-do where I was going to throw some of this code in a thing called Fragment Shader Common. And then, if we open up GPUView, and we open up the, sorry, not GPUView. Yeah, GPUView default shader. So if we open up this file, we see there's this include here. I want to include something called frag. I want to include something called frag com. Like above here, I want to do another include that's for like fragment shader common code, and tack it instead of just this one include. I just want to include another string that has some common code that's used between all shaders. And I don't know what I'm doing. I don't know why it's not working correctly, but I know that that's an easy task that I could do. So we might as well do something, and then kind of try to figure this out later. So let's look at the fragment shader code here, right? So we're saying we're going to take a whole bunch of fragment shader code, and we're just going to throw it up here somewhere. And we're going to keep it wrapped in kind of like these defined, undefined things. So it's still going to have like a, it's going to make it kind of bulky. Yeah, okay, we're going to roll with that. We're going to roll with that. Okay, so I don't know what's going on. But I do know that we can stub in a fragment shader common code somewhere. And then we can try to maybe give ourselves some time to figure out what the hell is going on. But I just don't know what's going on. And so in our C11 file here. So here's our polyfills, right? And the GPU wire and GPU view, these are shaders that use poly OGL. So in between here, we want to make an insertion here where we create a frag common, right? So this is common, this is our new 34 here. This is frag shader common. So fragment shader common. No, we'll just call it frag shader common, right? Frag shader common. There we go. Frag shader common. It's going to be this thing here, and we're going to stub this in, right? We're going to stub this in, and I don't know what we're going to do to fix the problem that we're currently on, but we're at least going to stub this in and try to organize the project a little bit better. And then maybe after that, we'll have kind of figured some stuff out. I don't know. But I'm going to try to see if I can find some. I'm going to get some Kool-Aid or something. I'm going to get another packet of Kool-Aid. Maybe eat something really quick. So let's give us kind of like 16 minutes. We're going to take a quick 16-minute break to just be like WTF, and then I'll be back. But code to print the thing. Okay, let me check that out. But then I'm going to take a quick break because I just don't know what the heck. Oh, okay. So this is okay, hold on. Let me. Can I? F open. Wait. Okay, here's my file pointer. I'm gonna look at that file pointer. So hold up here. So is this a tile map? It outputs a bitmap with zeros and ones to represent black and... Okay, yeah, so you're outputting like a tile map, right? You're doing like a monochrome tile map encoded as ASCII, right? Is that, do I understand that correctly? It's a monochrome tile map encoded as ASCII characters. And then you have to have some type of thing that can properly render. Okay, yeah. Okay. So that's the part I'm missing, right? Because that was, like, I'm looking at this and I'm like, how do you quickly get, like, a graphical snippet, right? Okay, yeah. Okay, cool, yeah. Okay, cool. I'm gonna put that in my things, right? So let's, so image... ASCII binary to image. I'm gonna also say that's an ASCII bitmap. And I'll take your, what is this? Where are you? Code to print the image. I'll take the code to print the image. So I'm kind of looking at this. I guess you can't really see what I'm looking at. I'm just taking your links here. I'm gonna put those in here. RBS, makes fractal. Okay. So, yeah, I'm gonna take a break, because I'm like, I'm kind of like, we're gonna take a break, and then after the break, I'm just going to do some refactoring that needs to be done anyways to give myself a break, because I just don't know what's going on. I don't know what's wrong. Like, I don't know what's wrong. I don't know why it's not rendering correctly. I don't know. Like, all the math seems to be correct. I don't know. I'm kind of like, just Okay. Yeah, 16 minutes. Okay, so let's give it a roll, and I'll be back. Break. Okay.
Hello. I have always suspected that my cartoons lose a lot of potential.
What movie could have been over in 10 minutes if the main character wasn't such a fool? Don't swim to the drop-off, Nemo. Okay, Dad. Credits. That was the most predictable reaction for a kid his age though. Mullen shouldn't have put him down in front of his new friends and been so rude about his fin. That should have been a private conversation. Exactly. Nemo was always going to swim off because Mullen was overprotective for his entire life and putting him down when he wasn't otherwise going to swim out was the final straw. Conversely, Mullen was always going to do that because he lost his wife and kids to the Barracuda and wanted to protect his only remaining son. What I'm saying is free will doesn't exist, but seriously, this question sometimes misses the fact that characters' actions, though sometimes stupid, may be consistent with who the characters are, but then we would have never seen him touch that butt. Now would just lead to a different kind of film where an angsty child rebels in a different way, paints himself black with squid ink, acts depressed and listens to bands like My Nautical Romance and Fall Out Boy. I present to you, Nemo the Emo. Finding Emo. Jurassic Park if Hammond actually spared no expense. Hammond spared no expense. 15 minutes later, I told you how many times we needed locking mechanisms on vehicle doors. How the F do you have a T-Rex but not locks on the car doors? Because they can't reach the door handles with their tiny arms. Don't stiff your it, guys. Also don't put all your it into one guy basket. Aladdin. If Jafar would have just paid Aladdin what he promised him instead of betraying him at the cave, he would have had the lamp and become king, be mighty powerful. Aladdin just wanted his money in return for the lamp. For real. It's not like Aladdin would have been able to do anything about Jafar using the lamp, right? But no. Jafar is the basest sort of villain. He's lowly troll. He simply cannot resist an opportunity to screw someone over for his own sadistic amusement, even when it is directly counterproductive. He wasted time trying to get Aladdin to give up his only leverage when he could have just pulled the man up and completed the deal. Something else that has always bothered me is that if Jafar can take the lamp and get 3 wishes before it is returned to Aladdin, it would seem like Aladdin could have let Jasmine have 3 wishes before setting the genie free. She could have ended poverty and made sure Agrabah's harvests were always bountiful. The visit. Kids, we're going to visit our grandparents. Mom, I don't want you to go, but if you feel like you really want to go, I'll drive you to their house. Mom, hey, you're late, my parents. I'm calling the police. The end. The ring. Girl 1. Hey, do you wanna watch the tape that kills you in 7 days? Girl 2. No thanks. Not a movie, but 13 reasons why. The effing kid just couldn't listen to the damn tapes. It's literally the first thing she tells him. It's what everyone repeats to him a million times. He runs around, asking PPL instead of listening to the tapes. Imperial Officer 1. There goes another one. Imperial Officer 2. Hold your fire. There's no life forms. Imperial Officer 1. Dude, we're looking for an inanimate set of plans in a galaxy full of sentient robots. Imperial Officer 2. Oh. Right. Written and directed by George Lucas. Not a movie, but Breaking Bad would have worked out much better for Walt if he had just swallowed his pride and allowed his old friend to pay for his cancer treatment. I know, right? My rich friend will pay for everything and all I have to do is play Candy Crush and eat Pop-Tarts, but you know what, I'm going to make drugs and kill people instead. Or let my rich friend pay for everything and still make drugs and kill people. Best of both worlds. Literally not picking Anakin to be Padme bodyguard when the sexual tension between them is thicker than Jabba, or just buying his mother out of slavery. He is supposed to be detached from her. Would sure be easier if he knew she was safe. Reservoir Dogs. I dunno, Joe. This heist seems kinda risky and dangerous. Yeah, I'm not actually sure everyone in this crew is on the up and up. It's off. Over the hedge, RJ decided to be a dum-dum and steal all of the bear's food. Like, what did he think would happen even if he didn't accidentally wake him up? The bear would still have woken up a week later and probably would have known it was RJ. Dang, I haven't heard someone reference Over the Hedge in years lol. No Country for Old Men. Never go back to the scene of the crime. Dart also, if you find a duffel bag full of cash and decide to keep it, check it for tracking devices. Take the cash. Leave the duffel bag. Now Llewellyn and Carla are living comfortably in an isolated Idaho ranch they paid cash for. Cars. If Lightning McQueen listened to his crew and changed his tires as ordered, he could have won the race. Or if he'd have let Mac go to bed, maybe the back hatch wouldn't have been opened, unchecked, etc. Or if he hadn't have been speeding like the little daredevil he is, he might have gotten to the second race, maybe knowing this time why tires are important. Or if the cars weren't even cars. Look, Cars to me falls under Belisairio's principle. Some movies don't have to make sense to be enjoyable. I think it makes sense. It's just that the main character is an arrogant buffoon. It's the entire point of the movie, to force him into a sink or swim situation where he must grow. Not the main character, but don't reopen the beach for the holiday weekend in Jaws. Any horror movie where your friends are dying one by one. After the third one, you say F it and leave. Third, after one death I'm out of there and not coming back without the cops. I would too, but some people don't have common sense. They wait until the I can't believe this is happening to decide to run. Any movie where the main character says there's no time to explain. This made me think of Princess Bride. Let me explain. No, there is too much. Let me sum up. Such a good movie. I suppose a summation is good enough. I first watched that film last month. I definitely regret not seeing it sooner, as it was a great time from start to finish. 50 Shades of Grey. Anna, you're an abusive stalker with serious emotional trauma. Seek help. You're using BDSM as a mask for your trauma and abusive tendencies. That is bad BDSM. Star Wars Episode 1. Not exactly 10 minutes, but Padme could have bought Anakin's mom and he would have probably never turned to the dark side. Republic credits may not be worth much on Tatooine, but I'm sure one of her jewel-encrusted headdresses is. Or if anyone had asked Anakin how he was doing and if he wanted to talk. But the story of the prequels is essentially the old Jedi were stupid and kinda deserved it. Qui-Gon. Hi, I'm looking for T15 hyperdrive. Do you have one? Marta. We got one. No one else has one. I can tell you that. Qui-Gon. This guy is obviously ripping us off. Let's just get the part from someone else. They never find Anakin. Never free him and everyone in the universe sleeps well for the next 200 years. If MR and MRS Bueller were anything like my parents, the movie would have been called Ferris Bueller's Day at School. If they were anything like my parents, they would have called my bluff, taken me to the doctor's office, and found out, to my own surprise as well, that I had bronchitis. Forget movies. How I Met Your Mother took 9 years. A 5-minute story. Kids, I was at a wedding, and your mom was the bass player. The end. And at wedding, Aunt Robin's. I would like to bang her again. Is that cool with you guys? Isn't this also serendipitous? Pretty much anything on the Hallmark Channel. Wait, let me explain. I am dying of a women's disease. That's Lifetime. Hallmark is 25-year-olds finding love. Lifetime is 40-year-olds being miserable. I'm from the UK. Do they just show bottom of the barrel rom-coms? It's the bit that end up on the floor of your summer. They have like 3 plots they rehash 20 times a season. Batman Begins. The Waynes shouldn't have left through the side exit of the theater. Just call Alfred and wait out front. Just hire a driver to pick you up at the entrance like every other elite rich person. Dad, just book an Uber. Whoa. This is a flashback. Shut up and follow me and mama. John Wick. If Theon would have just killed John. Considering they effed hun up pretty bad. Not only would we not have gotten 3 movies, but Theon would be known as the person who killed Baba Yaga. Being the son of a crime lord and worldwide recognition for killing the most famous assassin on the planet would make the Teresov family untouchable. Hi, is a car for sale? No. Where did you buy it? I'm a mobster's son with a literal bottomless checkbook. Murray's Classic Vehicles. Drop my name John Wick, and they'll give you a good deal. Hey. Thanks. Murray's Classic Vehicles. Drop my name John Wick, and they'll give you a good deal. Oh. My family knows Murray and we do business. I see we work in the same circles and it would be foolish of me to attack someone who has ties to my family's shop. the person who manages it, and quite possibly my family. Now, like a smart and calculating crime heir, I'll take my leave. Good day to you, sir. And he could have taken the puppy. Then he would have killed John Wick and had a puppy. Yeah, but he didn't know who he was at the time. He thought he was just some guy that disrespected him. He probably left him alive because he wasn't out to murder him. Just teach him a lesson. If there was a fallacy in the movie, it was where they captured Wick and the boss takes his whole crew except 2 guys out while they strangle Wick. It's the same dumb mistake all these villains make. Ahurmar. Bond. Let me tell you my whole plan and then leave you strapped to this table with a slow moving laser running across it. I will now leave the room and will just assume that you'll sit there and die. The movie would have been over had Mob Boss and his goons stayed there to ensure Wick died. Or you know, just put a bullet in his head instead of trying to slowly suffocate him. Star Wars, after discovering that Anakin could be very powerful with the Force, but had a lot of fear and attachment issues over his mother, the Council sends Obi-Wan back to Tatooine to buy his mother out of slavery and relocate her to Coruscant in a safe neighborhood. Anakin now knows that even without him in the picture, his mother will live a safe and happy life and can detach from her much more easily than leaving her alone on a savage world. And even if he isn't able to fully detach from her, he never has the impetus to slaughter the Sand People and kickstart his descent to the dark side. It's not a sure plan, but certainly one that would produce a version of Anakin who ends up resenting the Jedi just a little less. Maybe even enough to no slaughter younglings in the future. TBF Palpatine would have engineered some other tragedy for her. Please, Lightning McQueen, change your tires in this pit stop. Okay, tires wouldn't have blown in the last lap and he would have won, as he was comfortably leading the race. No need for a tiebreaker race. Emperor's New Groove.
Okay. Let's close this. Okay, so let's try to get this fragment shader common code in. And then after that we'll try to debug some more. But right now I don't know what's going on. So let's take this and overwrite this 34 here. And we'll say we have 42 systems now. This will be a 42 here. And this is going to get cluttery really quick, isn't it? Because we got a lot of stuff here. Oh well, I guess. So let's go open up the so let's go look up the libchan top and bottom. Let's go open those up. Okay. And in the libchan top, we want to... Let's put this over on the right side. So let's put the 2 library chain files over here. And we know that... We're going to go look for this, so... before we do that, though... right, we added another system, so... We're going to say that this is, you know, 42. And the max value is 42. Make sure these match. Then we're going to go find number 33 for a second. So we're going to scroll all the way down here. Find number 33. Which is poly OGL. We'll copy all that. And we'll paste this. And we'll highlight this. Right, so the second one is going to be called fragcom, right? So this is now called fragcom. And it's the 34th system. And now we just have to change these numbers, right? So we have to change these numbers. So this is the painstaking part. 36, 36, 37, 37, 38, 38, 39, 39. This 39 becomes a 40. And then after 40, we got, what do we got? Yeah, 41. And this is a 42. Okay. Now we're going to go look for poly OGL again, because we're going to look at the function file. So here's the function file for poly OGL. We're going to copy all of this, paste it down here. And right, so this second poly OGL here, we're going to rename that to fragcom for fragment shader common code, right? So fragcom.f. And then we're going to change the numbers, right? So we're going to number this. We're going to say, hey, 33 becomes 34, right? 34 becomes 35, and we're just going to offset everything by 1, right? So 35, 36, 37, 38, 39, and then we got 40, 40, we got 41, and then after that we got 42, right? So 42 systems. And that should be everything for this file, so let's close this. And over here we have like a, let's go find poly OGL again, poly OGL. Okay, so here's poly OGL. And let's copy all of this, paste this over here. And wherever we see poly OGL in the second section, we're going to rename that to fragcom for fragment shader common code, right? Fragcom. And fragcom. Okay, so we have some more redundancies here to make sure that we do not screw up. So we have this kind of list here. So let's look for 33 here. And in 33, we can already see it right here. We're going to take this, if, error, endif. We're going to take it, and we're going to paste it. So now we got two poly OGL things here. And we want to rename the second one to fragcom, right? So fragcom. And then we want to take this whole list here, this whole list of numbers, and we want to overwrite this one here. So we're going to go all the way down here like this, and then go, bam, paste that in there. And now this is the 42nd system right here, 42nd system. Poly OGL, so that's good. And then over here, we also want to make an insertion point right here, and call this fragcom, and slide these numbers up. Yeah, slide these numbers up, right? Yeah, okay. I did something stupid here. Poly OGL. Okay, hold on. Poly OGL is 33. 34 is fragcom. 35 is GPU. Oh. There's no GPU wire in here. Let's change that. So GPU wire needs to be in here. So GPU wire is 35, right? So if we go from here to here, yeah, okay. Fragcom is 34, so GPUView, GPU wire. Okay, cool. Now I'm kind of concerned that maybe we don't have GPU wire in this list, or we don't have GPUView. So GPU wire and then GPUView is right there. GPU wire is there, GPUView is there. So it just wasn't in our undef list for some reason. Okay, so libchan is solved, right? So cute bug. Let me take a look at this. Oh, that's pretty cool. Yeah, it almost looks like you can kind of see like a what's that pyramid of? It's like a pyramid of factors or something. I forgot what it was. We learned it in calculus, but there's some type of pyramid of like numbers, and it kind of like when you take the pyramid of numbers and you color it, you start to get this like triangle pattern. I don't know what it was called though. Okay. So let's go open up some of the other files. So libchan, and then the next thing we want to open up is fmacros. So fmacros, we want to open up the bottom and top file. And let's start off with the top file. So we made an insertion after 33, so anything, this doesn't get changed, but this 37 is probably a 38 now. Tau Depot, yeah, this is a 38. And then over here, this 39 is probably a 40. Tau sync, yep, tau sync is a 40. Yep. Okay, and then down here, we're going to make an init none function. So what do we got here? Init none. Then you have a list of functions, and we are going to every time we make this, we always so anytime we make these functions, we always auto-generate them. So if the list isn't correct, then the code wouldn't be correct either. So we're going to trust that this code list is correct and make an insertion. So GPU wire, so is GPU, hold on here for a second. GPU wire, and then there's GPU view. Is GPU view in here? Yeah, GPU view's over there. Okay. So GPU wire. So this is the init nones, right? Init none, yeah. So right beneath poly OGL, we have fragment shader common. So fragcom. Okay. So we're going to take all these, copy them. Or we're going to just copy this whole list here. And then we're going to nuke everything in here. We're going to nuke everything in here and rebuild it. And this is getting pretty long. This is getting to the point where I really need to make some type of auto-generating script for this. So let's just run fark. And now everything's kind of there. And then let's just kind of get rid of the spaces here. Oops. I am just not with it right now. I'm kind of feeling slightly delirious. Like, I have been working for a while, though, so... Okay, cool. So, that's all we need to do for this file. Yeah. We could update this list, but I'm kind of sick of it. So, eventually we'll rehaul this and maybe make this list better, but right now I just want to get things working. So, in the bottom file here, we kind of interlaced everything, right? So the init and the init none functions are kind of like interlaced. And so we want to look for poly OGL, which is 33. And then make an insertion, right? So we want to duplicate that. And we decided that the fragment shader common code, so fragcom, was going to also have an init none. And we're going to paste it right here. We're going to make this a 42. Okay. So now that we have that, we're going to... Yeah, so we're just undeffing it here, right? Yeah, okay. So we need to go into the functions file and the silence file. So we need to go into main and put something in here. And then we also need to go into our silence system. Silence dot data. And we need to add to this list. So this list, right over with poly OGL, we're just going to say, hey, UO8 fragcom. And we probably should have done this after. Put a little dash. So we need to edit this and add that code in, but for now we'll keep this open still. And it's right underneath poly OGL, so let's kind of highlight this for a second. So beneath poly OGL, we're going to create this thing called .fragment shader common. We're going to turn logging on for this system. Okay, so now that we've done that, let's go over here. And this is code that initializes after the window is open, right? So GL bindings this is the block that comes after the window code. So we see 17, and we see that Gina win is 15. So this is after the fact. And right here, poly OGL is right here. So we want to go right here, and we want to make an insertion. And this is going to be called fragment shader common, right? Frag com. Then we're going to take all this stuff here, and we're going to move it up. Right? So we're going to move this up here. And this is going to be 42 now. And then for our control F help, so we have... Oh, actually, this is the control F help. For the actual function calls, so right here, we're going to make an insertion point. Control D. This is going to be called frag.com, fragment shader common. It's going to have an init none function, that's correct. And we're going to take these and we're going to slide these numbers up. And this is going to be 42. Okay. So now that that's kind of stubbed in there, we can close this file, right? Yeah, we can close this file. We can close this file here. We are not going to close this yet because we need to AAC 2020 boilerplate. You know, I swear that was already a shortcut. I may have not just reloaded my shortcuts in a long time. Hold on. So yeah, we have a shortcut for that, but it looks like... I'm going to make an insertion, but I'm going to guess that my shortcuts just need to reload. It's been a while. Okay. So today is not the 13th, it is the 15th. So it's been 2 days since I reloaded my shortcuts all the way, it seems. According to that timestamp. Unless I just didn't type the shortcut right. Let's do AAC 2020. Boiler plate. Why did I call it boiler plate? I don't know, I didn't spell that right. But that doesn't work either. So let me say AAC up 2020. I know I'm doing it on some other screen. Boiler plate. Okay, so what we're gonna do, we're gonna take some time to reload our shortcuts because I was expecting this to work, and it was 2 days ago. I guess you know, one of those days would be our no work day, and then the other day would have been another work day. So maybe at the end of one of our work days, you know, Sunday comes, it's not a work day, so we don't reload our script. So not as much time has really passed since we reloaded. We actually have, it's a reasonable amount of time. So we're just gonna reload this. And while that's reloading, I guess we can, I don't know, I guess we'll just have to wait. So this can take about 5 minutes. I'll actually start a timer. So split timer. Okay, so start of the stopwatch. We'll see how long this takes. So it looks like we need the means, F means RT for a second. Well, what the heck? Did not... TR means. TR means. So did we screw this up? So we got a shortcut here where we use TR means right here. And this TR is not top right, it's more obscure. So also, this looks duplicated. This looks like identical. Like, what did I do here? Yeah, it's completely identical. That means that all these are... Oh, so this is supposed to be lowercase, right? Wait, this is a TL. So this should be like a TR... Oh, the case sensitivity didn't replace correctly. So this needs to be like a bottom left. This needs to be like a bottom right means. And then right here, once again, this needs to be a top right lowercase. This needs to be a bottom left lowercase. This needs to be a bottom right lowercase. This is a TL capital. And these are all TL. So that's not right. TR, BL, BR. T underscore R. T underscore R right here. We got a T underscore R right here. We're just going to put that there. We're not even going to worry about it. Because that's kind of... It's an obscure kind of variable. Oh, we already have that, huh? Okay, we're just going to stick with that. And we're trying to reload this again. Beep boop, yep. Yep, exactly, yes. That is what's going on. So yeah, every time I type, as I type, if the shortcut's reloading, it's just going to go boop, 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 and it's kind of loud because there's no volume control on it. Like, I can't, if I turn down the volume, it does not actually... Okay, so what do we got here? TL means. Okay, TL means. Let's go look at that. So TL means, and it's capital, like, so this is the TL means. Oh, so this TL here, this needs to be a TR. This needs to be a BL. This needs to be a BR. So yeah, if I turn down the volume here. Oh, I guess that does. Never mind. Okay. So hold on, let me reload this one more time. Reload. I just want to make sure. And that'll take some time, unfortunately. But, oh, also, while we're here, taking our sweet time here. So, the README file in the repo, I've been putting all my diagrams. So, there's like a ton of diagrams in here in the README. So we got like an index and got about, developer time costs. Now this doesn't really do anything, right? Because I made these little headers, but the headers don't, right? I did not kind of do this in the standard kind of way that you're supposed to do a markdown file. But then we have all these cool diagrams and things. And some diagrams that you haven't seen before, because they're kind of far future kind of diagrams for how I'm going to do the level design and how I'm going to make the Metroidvania-ness. So yes, there's also going to be, there's fractal auto tiles, but then I also have designs for how I'm going to do a Metroidvania thing, where I have like a whole bunch of levels, and I'm loading like, so right here, you have a level where you are, right here, in the center, and then you have a level to the left, right, top, bottom, and then in the corners. And then you have connecting hallways. So if you want to zoom out, you can zoom out and see like all these levels. And then the other levels are going to be on disk or something, so you can't zoom out any further than this. But, yeah, anyways, that's going to be cool. And I haven't showed anyone that diagram yet, so nobody knows what that's about. Okay, so it looks like the word academia. Oh, no. Anime dude. Oh, God, yeah. Let's see what I did here. Anime dude is right here. And this is a correction on their name. And then anime dude is over here. Okay, so let's just match the case. And match the whole world only for a second. And let's just remove this thing. And then if we see this somewhere as well, we'll just kind of... Okay, that's okay. Okay, that's over there already. So we'll get rid of this one as well. And then this is kind of like their name, but it's kind of like this. So let's see if we can get rid of this as well. So that's over here. Let's take this one and remove that from here. Now let's take this one here. And let's say, you know, if we type it exactly correctly, we'll have like a little thing here. I don't remember the hex code for this, because I usually use a code. I guess it's U plus 2611 for a checkbox. If we type it correctly. Okay, cool. Let's try to rerun that. Reload that. Cluster size. Okay. So now let's... So some things are kind of, like, scattered where... Right, everything is kind of... The shortcuts are kind of not very well organized, right? So the idea is as I come back to shortcuts more and more often, I can choose to organize them a little bit better. But for now, we just want to get it working, so... Oh yeah, so... Let's go over let's try to go back to the diagrams, so... Diagrams, right? So you can zoom out to see up to, what, 1, 2, 3, 4, 5, 6, 7, 8, 9 levels around you, right? So you can zoom out to see 9 levels total, right? So a level to your left, a level to your right. And so the idea is that you can zoom out far enough to where you can get an idea of where you are in the world, right? So you can't zoom out any further than this, but you can zoom out far enough to get an idea of where you are in the world map. And these connector rooms, the connector rooms are just going to be copies, right? So this horizontal connector room here is going to be identical to this horizontal connector room, identical to this horizontal connector room, and this vertical connector room is going to be identical to this vertical connector room. So that means as we're designing things, we'll have to make sure that the exits, if we want an exit, we're going to have to make sure the exit is completely lined up with this kind of template here. Now, we may want to eventually make it so that, you know, we don't always have exactly 4 exits to a room. So, because this design could really limit you when you're trying to make something, and it's like, hey, if you're in this room, you can exit to the left, right, up, or down. We probably don't want always to have the option to go in all directions. Now, you could just change that with the level design and just block off this area, but we don't want to just, it'd be kind of weird if it's just blocked off here, right? And there's a hallway, but it's blocked off, and the game design says, oh, you can never go down that hallway, that's just the way it's designed, but there's an actual hallway there. Like, that might not be a good way to go. So if we don't want to go this way, we might want to delete this hallway some way. So we'll have to think about how we're going to, like, manage the level maps on a meta level. But that's going to come very far in the future, because we don't even have the tile rendering correct yet. So we don't have to worry about this till quite a long while. So what do we got here? Okay, so BL means. So BL for bottom left, right? And breakpoint list. How about, no, breakpoint list is not something I've ever used that much. BL I use much more often when it refers to bottom left. So we'll just do a O2 on there and just call that good, and then kind of reload this and see how far do we get. We got like almost halfway through the shortcuts before we collided. So this is the thing, like sometimes it's just a disaster sometimes, right? Like it's hit or miss depending on what kind of shortcuts I've made. where I really, you know, if I had checked ahead of time before I typed it out, right, we wouldn't be having this problem right now. But we made a whole bunch of synonyms, and it took a lot of time to make, yeah, whatever. I mean, this is just the way it is for now. This is why I only reload my shortcuts like once a day, because it just takes too long. It used to be really fast, but, yeah, so like these diagrams here. So, I'm going to, I decided that, since I'm trying to do everything in terms of a 512 by 512 texture, I'm trying to figure out, well, how do I fit 16 levels into one texture? So I'm like, okay, the level data for each room is going to be like a 128 by 128. Okay, fine. 128 by 128 pixels stores one level worth of data. Okay, so what do all those pixels get used for? Well, the main game is going to be 64 by 64 tiles. So when you're inside of a room, the game tiles are 64 by 64, right? Okay, well, we have a 128 by 128, so we're going to have to divide that, right? So, okay, cool. So now we got these four partitions. What are we going to do with these 4 partitions? Okay, well, how about we have a parallax scrolling background here. Then we have a static background, so it's a background that does not scroll. Then we have the foreground, so this is actually where the game action is happening. And then we have a static foreground, so this is like for non-scrolling elements that are in front of the player, right? So that we can get some really rich depth. So if we look at like, let's look at like Mega Man X 2. And see if we can find some interesting screenshots. So images. We could just watch a playthrough, really, if we wanted to, right? We could do... Here, you know what? Let's just watch a playthrough really quick, because then we can stop at where I want to stop. Okay, so if we take a look at a Mega Man X playthrough, we can find a video here. Yep, that seems complex. AF? Yeah, I mean, it is, yeah. Okay. So obviously, this is like an old school game, and it has more layers than I'll be working with, right? Like, you look at all that parallaxing, we have like 4 layers. We got like this foreground, we got this midground, and we got 2 backgrounds. Actually, we got this solid background here. So we got like 1, 2, 3, 4, 5 layers going on. What? Oh, actually, no. Yeah, no, that looks about right. Okay. So let's talk about... Just wait for it. Bam, right there. Okay, look. So we have this red beam right here, I would call static foreground, right? It's in front of the player, but it's not doing any parallax, right? So it's kind of connected. It's connected to the same ground that the player is on, right? So we may want some places where we can draw kind of features like this, okay? So we got static foreground here. And then in this game, we have a static background. So you see this kind of interior right here. It doesn't scroll, right? So, and then in the background, we have a parallax background. Then we have a static background. Then we have the midground where the character is. And then we have the foreground, right? So you can see kind of the 4 layers. I mean, they have more than 4 layers. But when I'm trying to talk about the layers that I'm using, this is kind of how the breakdown is going to work, right? So in the game, right, we could have, like, bombs that are stuck to the wall, right? So if we want to make it look like a bomb is stuck to a wall in the background here, then we want to create some static background so that it looks like, so it doesn't look like the bomb is just kind of, like, floating in air. It looks like it's actually stuck to a wall and that you passed by the bomb when you walked by it, right? So... Let's turn this down, because I don't want to get a copyright strike for the sound here. So right here, okay, this portion right here, static background, and then where we see these legs here, it's the parallax background, right? Right, so you can see what I'm talking about. So right now, way in the background, we have parallax background. The stuff that they're interacting with, that's the game tiles layer, right? And then eventually we'll have some more kind of like static backgrounds. There's no static background yet. They're messing with the midground, right? So they're on the midground, right? Okay, more midground stuff. Okay, so right here. So the robots here are the static background, whereas this blue stuff right here, the blue stuff is parallax background, whereas this little green here and this purple are static background, right? So you see them scrolling at a different rate, right? So right there, you saw when you jumped through there, that was static foreground, right? So right here, the purple static background with parallax background, and then right here, right, you have this in front of them, that is static foreground, right? So in order to get kind of this nice level of detail, when we're partitioning things, we need to make sure we have enough data for all that. So we're saying that at minimum, if we want to make something look nice, we are going to need a little bit of scrollingness, right? A little bit of scrolling parallax background, a static background, the game tiles over here, and then a static foreground, right? Okay, cool. So once we have those kind of three layers, we can start to say, well, we only have 16 tile values, so let's kind of split up the bits of the pixel to do some interesting things. So we're going to use 4 bits of the red channel to create geometry tiles. We'll use another 4 bits of the red channel to create bomb tiles, right? Because the game kind of revolves around bombs. So let's give ourselves the ability to have at least 16 types of bombs. Then we'll use these 4 bits of the green channel to create sprites. And then we'll use these 4 layers, these 4 pixels to create lights. Okay, so that is the red and green bits. What about blue and alpha? So blue and alpha bits, that's a total of 16 bits, right? 4, 4, right? That's 8. 8 and 8 is 16. And we're going to partition the bits spatially on a tile. So we're going to take one full tile. So this right here is one full tile. And we're going to subdivide it into thirds. So you might be wondering, like, thirds is very weird because it's not a power of 2. Why the heck am I doing this? Well, if we divide it like this, we have one bit that represents if this subdivision exists, one bit that says if this subdivision bit exists, one bit all around telling us if this subdivision exists or not. Then in the middle, these 4 bits are going to be for material, right? So these 4 bits determine, right? So there's 16 possible materials, right? So these 4 bits are going to determine the material type for all of these squares here. So we're not going to have the fine level granularity of being able to specify the material for all of these. It's going to be specified by this center here. Okay, and then here is going to be a bit mask for different tile subdivision sizes. So we have a 1, 2, and 3. Okay, these are subdivision levels. So at subdivision level 1, it covers this entire third, right? At subdivision level 2, it's 1/3 of 1/3. And then at subdivision level 3, it's 1/3 of 1/3 of 1/3. So it's going to kind of look like this, where we have subdivision level 1 is kind of like going to fill the entire third. And then subdivision level 2 is going to be 1/3 of that third. And then subdivision level 3 is going to be 1/3 of that third, right? And so at the lowest subdivision level, we kind of have something like this. So this is an entire tile. This is one game tile that we have decided to subdivide like this. And so we can use this to create railings, right? So we can take this little tile here and then make the renderer automatically connect this to this, right? If this is on and this is on, it's going to automatically connect a railing to it, right? If this is on and this is on, it's going to automatically connect a railing. And so what we're trying to do is we're trying to get some fine-grained details so that things kind of look more interesting, right? So we don't want all the tiles to be exactly the same size. We want some coarse-grained detail and some fine-grained detail so that the renderer just will look, so the levels will just look very rich and look nice. So, right, so we're going to take these tiles, right, and then we're going to procedurally connect them, right? So, this is one tile, and these are like sub-tile details that you're looking at. So that's some crazy rendering stuff. And then I wanted to get a visual of like, well, how big is this little 3 tile here? How big is this little 3 tile here compared to an entire tile? Well, the entire tile on the y-axis would be this, right? The entire tile on the y-axis would be this. And if we're looking at this subdivision level, it's this tiny. So that's a very tiny level of detail that we can get with not using too many bits, right? So I don't want to use too many bits because, remember, we have all this stuff we want to say. We want all these different layers of parallax, and we want to have like 16 level slots loaded at once into a 512 by 512 texture. So we really got to think about how we're going to efficiently use that memory if we really want to get all of this awesomeness within a very small texture. So that's kind of the basic data layout, and I think that my shortcuts are running again. Yeah, I could see that kind of hurting. Right, because it's kind of this diagram, and yeah, I mean, yeah, it's crazy. It's crazy. It's complete crazy, insane stuff, and it's gonna be. It could be a year before I get that far. I think. I don't know, because there's just a lot of things I have to add first, right? I have to actually start rendering the. So I have to have the base material editor. So PAINT5D is the base material editor. Then I have to have a fractal tile editor that draws with the base materials to create fractal tiles. Then once I have fractal tiles, I can then start generating levels, right? And I can start to create a level editor. So yeah, this is going to take a while. It's going to take a while, but that's kind of the plan. So as I get these ideas, I get a lot of these ideas in the shower. Right, so I have like a notepad. I have a plastic notepad in the shower, and I start writing things down when I'm in the shower. And yeah, so it's a pretty ambitious kind of thing, right? So let's close this. That only took 23 minutes to load all that stuff. So let's make sure this works. So let's oh, we gotta do gunmoji. Okay, so anyways, I just wanted to, so yes, the shortcuts are indeed loaded again, so we can go back to figuring out what the heck we were doing. So first thing is, let's take our shortcut file, let's put it over on the other monitor. And, so what is that? So that's, we can hover over, right? So do you just type it, or do you have to do anything special? Oh no, it just does, it's text replacement, right? It's just not, there's no fancy escape code. It's just type it as is, and then it replaces it, right? That's my understanding. Okay. I use tab to autocomplete. Really? Okay, so you can do like and then tab. Oh, that's not what I expected. Oh, okay, got ya. Okay, got ya. Yes, autocomplete. I like, I'm a fan of auto-suggestion more than I am autocomplete. That's just me. What I really hate is when you're using autocomplete and it covers up the code you're trying to look at. That annoys the hell out of me. I know there's probably a thing to, like, swap it, right? But it's annoying when you're trying to, like, it wrecks your flow sometimes when it's, like, covering up the code. But anyways, let's put this diagram. Let's just close this diagram. We don't need to look at it right now. I actually like this thing here. I'm gonna take this because this is a good Mega Man X2 is a great explanation of how I kind of like want my tile system to work, right? So I'm not doing like, I'm doing auto tiles, but I really like how they really thought about their layering system here. Now, as a kid, I did grow up playing these games, so I was like 6 years old when I played Mega Man X for the first time, somewhere around there, probably around 6. I'm just gonna make a... I have no clue why. I'm just making notes on my other monitor here. Okay, cool. So we can close this as well. Never played such games. Yeah, so just never like any no jump and shoot side scrollers. So let's think about what we got to fix here. So now we're hoping that we have like this AAC 2020 boilerplate is what we're hoping for here. So NSSBP paste. I don't know what that stands for, but maybe if we use it enough, we'll remember. And so we just want to say, like, anywhere where we see this color, we just want to replace it with the proper casing. So this is going to be frag common, right? Fragment shader common code. And these two are uppercase, right? So these are uppercase. Fragcom.f, because it's the function file here. And we have init none here. Okay, that's fine. Okay. So now this is kind of stubbed in. And we just want to stub it in for now. We just want to get it working. And we also want a... just a fragment shader thing. So, let's just save this for now. Let's just save it as fragcom dot fraf or fragment shader code dot underscore. Okay. So in our libchan top file, in the function section, so now this is the data section right here, but in the function section, which looks almost identical, we want to include before fragcom.fragment shader code. And this is, you know, before right, so we want to include this, oops. We want to include this before fragcom.f. And this one is we don't have much room, so we'll just say after.fra. We'll just kind of like use, sure, how about some stars, right? Whatever. And we also have to add this to the build system as well, right? So it's not... Well, let's just see if we can get this compiling first. And I'm going to throw this up to the top here again, so that I can read it as I'm doing stuff again. Super Mario Bros. Anything shooting. Anything closer was The Legend of Zelda or Close Seasons for Game Boy Color, I guess. Oh, I played that. Oh, Super Mario Brothers. I never played Sega. Well, I've played Sega very few times. Yeah, Super Mario Brothers. Yeah. Now, is that just, is this because you're like, because you are RPG person? Or because, you don't like, okay. So let's try to get this running. And once we get it running, we'll kind of like stub some more stuff in here. We'll do some refactoring and all that good stuff, and so that looks like it compiled. Nice. So first try, cool. Once again, we still have a problem here, right? So that doesn't look correct, but we'll try to figure that out as we go here. The next thing I want to do is in the silence, right? We made a little thing here. In Fragcom, we decided, hey, it's not added yet, but turns out that now it is. I don't know why I have an X for yes, when, like, really we should have, like, a Y for yes. How about we change that right now, right? Like, there's... So how about Y's for yes rather than X's? I mean, it's kind of like, why do I care? But it's kind of like stupid, but it just seems more intuitive. A Y for yes rather than X. I guess maybe it's because I had like it was like a check mark, maybe. Now, you know, I'm just doing things that are trivial and don't matter. I don't know, never played much games, but probably because I always sucked at aiming or agility games. I have a friend like that. They're like a really good artist, and they suck at agility stuff. Like they can draw some crazy stuff and like get the anatomy all correct and all that good stuff. But when it comes to agility, oh, that's real agility. Never mind. I don't know how good they are at agility games, but they're more of like RPG game people. Okay, so we're gonna close this because that's all squared away. And we're going to move some stuff around, aren't we? So the first thing I want to do is look at, let's close this library chain file. Let's consolidate this, right? Because it's all good now. And we can close it now. New file, whatever the heck. Let's close. This was like a scratch pad. PAINT5D data. We're not really using this. I was explaining some stuff earlier, but none of this is relevant to what the problems I'm trying to figure out, so we'll close this as well. The keyboard bindings, we just want to set up the keyboard bindings and have U for setting this value here. So we don't really need that anymore, right? P5D bug. So let's close the keyboard bindings. We do want to keep this open, though, because we want to make sure that we know what the function signature is, in case we're confused. We want this diagram open. GPUView data, we can keep this closed, right? Because we already know that this works. Yeah, this is in the shaders, default shader, that's all good. We can close that. Okay, so now what we're going to do is we're going to steal all of this stuff here. we're gonna take it, cut and paste it for a second. We're gonna take all this, we're gonna cut and paste it. And this is not the most maintainable way to do it, right? But this is how we're gonna roll. So first of all, this is not going to be a file for having a main file. It's going to be like some reusable functions. So anywhere we see like main and function, whatever the heck, we can just get rid of these main shim macros. So main shim macros are getting out of here. So let's delete those. Anywhere we see main shim macros, we can remove this nonsense from here. And we can remove this from here. Okay. And we can say, let's just call it, let's call it com001, right, for common. And we'll call this, fragcom default, whatever. Cut and paste into GLSL source. Yeah, that's what we're going to do. Then up here, this is not going to be called PAINT5D. This is going to be called fragcom. And some of that refactoring should have already been done on the other file we cut and pasted this from, but, you know. So this is com. So you have like a whole bunch of section names for the same thing over and over. So this is going to be com001 for common. And instead of PAINT5D, this is going to be fragcom. And there's still some more stuff. So this is common stuff, common code. So we're going to... I don't know if the uniforms have to be declared at the top of the file. So that could also create some horrible problems for us. And we'll find out pretty quick if that's the case, so... well, actually, let's look that up for a second. So, do uniforms need to be declared at the top of the file? We're gonna assume that you don't have to, but we'll find it out. We'll find out. So this GLSL uniform stuff, like all this stuff, we don't need this. So this can get nuked. Okay, how about this? This airstring macro, we're gonna need it. We'll keep the commentary for when it was originally written. And then we're going to keep these, we're going to keep these, we're going to keep all this, that's good. And we're just going to rename this function, right? This is the function I'm looking at. Resolution width, resolution... So let's just say, this is a common function as well. So let's, now, main, this main function, we're going to get rid of main. We don't want a main in the common code. So we're going to, all this main stuff we're going to get rid of. Okay, type macros. Those look good. Yeah, so that's fine, that's fine. We can keep this. And then anywhere we see GPUView, we're just going to rename it to, you know, AAC 2020 fragcom, fragment shader common code. AAC 2020 fragcom here. And then up here, this function here, same deal. We're going to rename it to fragment shader common. And then after we have that, we're going to need to add this to our pipeline. So full file path to clipboard. And we're going to actually open up our build script, which we don't open up all the time, but actually we need to open it now. So let's open up this build script. And we should have build system executables, hard-coded PNG assets, and then we have optional delete old shaders from mod folder. Okay. Generate GLSL code from C99 code. So that would be where we're at here. So we got this like GPUView, we got P5D, whatever the heck. Let's just put it in the order in which it exists in the system. Let's put it in system order since this kind of seems to be what we're doing already. So let's just copy this chunk here. And we'll replace GPUView with fragcom. Fragcom. And that's all we got to do there, right? So boom, there it is. Okay, so fragcom, we got this .string file. That's cool. What next? We want to use it somewhere. So the first thing is, before we even try to use this, we just want to confirm that that we can get this working, right? So this fragment shader code doesn't really... We copied and pasted this, so we want the... I gotta take a break quick. Medicine's kicking in here. I'll be back in 16 minutes. Okay, I'll be right back. But yeah, puzzly games, huh? Alright. I'll be back. Okay, sorry. Uh, okay, so I actually need to, I'm gonna make some tea really quick. Give me like 6 more minutes. Half a minute? Okay, not too bad. So 6 minutes should be enough time to go upstairs, make some tea, come back downstairs. So I'll be right back. Yeah, so to make tea, right, you gotta walk upstairs, you gotta walk downstairs. You gotta get out the tea bag, you gotta refill the water. You got a Keurig, so the Keurig works pretty fast, but still. We'll wait for this timer to go down just because I want the timer to actually mean something, so. We can check Facebook now, because it's now midnight. We can waste some time on Facebook, trying not to get ourselves in any trouble. Okay, hold on, I'm uploading something to the internets. Don't know if that's true, but... Close this. Okay, so let's keep on trying to... Well, first of all, let's try to compile this, right? So I believe we're compiling, right? We're already compiling. That's not a problem, right? Yeah, that's not a problem. Cool. So we're able to compile. So we want to do some refactoring here. Ooh, goddamn, I'm going to spill my tea. So let's do some refactoring, and we got this fragment file here. And we want to include it into... actually, we just want to include it in here, right? So this is gpu.fragment. We just want to be able to do this. We want to be able to do this. Include, you know, .. slash fragment shader common dot fragment dot string, right? So we just want to be able to include it like that and see if it doesn't like blow up in our face, right? So that is the goal, right? To concat two strings together, right? We're gonna take two files and concat them into a gigantic string. I don't know if that's going to work, but let's give that a shot and see if. Well, I know that's going to work. I'm pretty sure that's going to work. My concern is that it's going to have a syntax error when we try to run the GLSL code, because it's not going to like that. I think GLSL can be kind of C. Well, actually, GLSL is based on C99, not C89. It's based on C99, not C89, and therefore we can probably mix function and variable declarations with impunity. But I don't know. We'll find out really quick, won't we? So let's go over here. Yeah, I didn't think we'd like that. So let's kind of like look at this and see what's going on. Undefined variable I resolution. Okay. So I do know why that is. So we were like, hey, let's make this a common function. And then we were like, and then earlier we're like, hey, you know what else we could make a common function? We could make this a common function. Oh, wait. I resolution is a uniform. And we can't really do that because with the way we're structuring our code right now, we don't have access to iResolution yet. It exists further down the file. So, alright, fair enough. So we're just going to, this was just a thing where I'm like, oh, it'd be nice. But let's not worry about this, right? Let's just cut this out, right? So really what I just want to do is put this function into a common file, right? So this is a functional, this is just like a utility method. It doesn't reference any uniforms, right? It's a pure function, right? It doesn't have any side effects. It does not reference any uniforms. It's a pure function. Okay, so if we cut that out, can we get this to compile correctly? So let's give that a run and see if that's any better. And if that works for us, then we'll kind of refactor our unit test code to run on this function file here. So we'll kind of like throw things. So give that a shot. All right. So that looks correct. Let's just go over here. Let's press the U key and then go over here. And this is the same BS that doesn't look quite correct, right? So that's what we've been seeing. This is off by 1. It looks like the off by 1 on the y-axis probably has to do with the inversion of our coordinates, so we can probably fix that. But okay, so that looks kind of cool. So let's start to refactor some of this. So let's take this, let's close this. And in GPUView, we have this unit test, right? And the unit test, in the unit test, we're calling this GPU unit test code function here. And here, within here, we're calling this function, right? We're using it over and over again and blah, 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 right? Yeah, right there. We want to use it let's make sure that that's... Hold on, so let's go into the main function file really quick and make sure that fragcom is actually exists. So let's go on lib main. Make sure that fragcom init none is being called. So let's go look for fragcom. Fragcom for fragment shader common. Yeah, so init none right there, it's being called. Okay, cool. So what we're going to do is we're going to take all this code we wrote and we're going to move it, right? So we're going to move, we'll keep this unit test, but we're going to move the, yeah, we're going to move this, though. So let's take all this code, right, the unit test, let's not, well, we don't want all of this. Well, there's going to be some duplication. So first, let's just cut and paste all of this unit test section. We'll copy it. Let's go over to the, let's close this. Well, actually, no, let's keep that open. Fragcom.data. And then down here, let's paste this. Fragcom functions. And then we're going to rename this, right? So, this is not GPUView. So this is going to be called... There's no fragcom main, though, right? There's no fragcom main because it's utilities. So... we can strike this out and just say, you know, no such thing. $23 for the conspiracy. And let's move this over here. Okay, so now anywhere we see GPUView ran or running, so we'll have to have a variable for that. So let's go back into fragcom data, and we're going to make a variable for that, right? So ran or running equals 0. And that's a U08, right? So a U08 ran or running, and you know, just a misc section, right? We really don't care what's here. Misc vars. Technically, if we want to be fancy, misc file scope variables, right? Want to be really descriptive. That's what's going on. They're file scope variables. Now, obviously, I know they're file scope variables, but it might be nice to use that kind of verbiage so somebody who's a little bit new to C code can see that label and be like, oh, okay, so that's what that's called, you know? And then that's not what we want. We wanted U08. Kind of force of habit. Okay. And this is not GPUView anymore. It is called fragcom. Fragcom unit test ran or running. And then over here in fragcom, instead of GPUView, it's fragcom ran or running, right? And then ran or running equals 0 equals 1. Let's match case here. Let's match case, and if we see GPUView, we're going to call it fragcom. Match case. Okay, so replace. We're not going to change that because, right, we moved it and it's a paired comment with something else. So let's not change that. We're going to change this to. We're going to change this to AAC 2020 fragcom. So fragment shader code common, and then this thing. Okay, cool. Then over here, we're going to take this, and we're going to replace that. We're going to place this, yep. Not replace that one. Okay, so now we're going to look for the lowercase, so TLCMD to turn that into lowercase. Turn this one into lowercase as well. and then we'll look for the lowercase. So fragcom halt, fragcom info any. Unit test code, right? Yeah. Okay, yeah. Okay, cool. So we've stolen that. And now that we've refactored that, we want to delete it from the other file. So GPUView.f, right? In the unit test code, this can stay, right? GPUView main, because this hackishly calls like asserts, right? However, this unit test code here, we're gonna nuke this, right? So we're gonna nuke this out of here. Bam! You're gone, right? And then over here, this unit test GPUView unit test code, where the heck? All this stuff gets deleted because we just pasted it into the other file, right? So we can keep the unit test section though, right? Because we're just gonna say this is still the unit test code section. It's just, you know, very slimmed down now, right? Because basically we're just hackishly asserting that the GPUView code is correct, but the unit test that we ran only tested that helper function, right? So, okay. So now that we've kind of moved things around, we've shuffled some things around, the next thing is in GPUView main, right? That would be in this fragment shader code, right? This thing here. So we look at function main, we need to change what it's calling, right? So inside of function main, it calls GPUView whatever the heck, right? This is no longer that, right? It's called AAC 2020 fragment shader common, fragcom, right? Fragcom rectangle source map to rectangle dest. Okay. And then we have all this junk. I don't know what that's about. Okay, so let's try to get this compiling. Hopefully, we haven't done anything really stupid where it's like we tried to refactor it and it totally blows up in our face and there's no way to fix it. So hopefully, this refactor is actually successful. But also we need to lazily invoke the unit test. So it looks like we're good here. Looks like the refactor looks successful. Let's press U. So yeah, the refactor is successful. I mean, the code's still broken for that shader, right? There's still a problem with the shader, but the refactoring worked. And now that that's refactored, we want to lazily, well, not lazily, well, sort of lazily invoke the unit test code. So this is GPUView, and we see in GPUView we have this kind of like ran or running flag here. And this is init. In fragcom, we want kind of the same thing, right? So in fragcom, we have a init none function. And in here, we just want to lazily invoke, instead of GPUView, we want this to be fragcom, right? So GPUView needs to be changed to fragcom right here. So this is going to be fragcom unit test ran or running. If it's less than or equal to 0, it hasn't been set, then we want to we want to run the fragcom unit test, right? So we want to run the unit test down here. This is a forward declaration, and that looks good to me. Also might be nice to indent it like that, because now we have this kind of line up here. You know? Sure, why not? And get rid of some of the excess spacing. If we really want to, we could do that. Now we're just being picky. So let's give that a roll and see what happens. Okay. So it looks like everything's refactored. We still got some problems on our hand, but it's refactored, right? So, cool. So I was thinking while I was writing this that what if the problem with our partial texture push not working is because the data, what if my renderer is actually correct? What if my rendering logic is pretty much correct, and those pixels are not being set in the correct spot, right? So what I would like to do now is this global location, right? We're remapping. I would like to just say, you know what? Let's comment this out. And let's, this logic here, we can just delete this. This is old logic, right? If this is logic, this logic is junk, we can remove it. And instead of using this, though, we're just going to pass it on to glow.x equals, you know, canvas user view ix. And then this is an integer canvas user iy. And this is temp. So I'm thinking we need to look at the entire bitmap again, because maybe, just maybe, things are not where they're supposed to be. And so if we undeclared first use, what do you mean? Oh, because we did this over here. Okay, so let's put this global outside of the define block for a second. So that way we can glow is for global. Okay. Now let's try to run this. Okay. So here's what we're going to try. We're going to do P for, no, U. Okay, you see this thing right down here? So everything should be exactly what, well, this is the region we're concerned with, right? So let's do a snip here. Get the snipping tool out. Break out that snipping tool. And let's do a sanity check. So let's take this. And we're going to file save as. Sanity check number 4. So we're trying to do all these camera zooms and things and be fancy, but we didn't do the very basic thing of, hey, why don't we look at the texture without distorting it, pixel per pixel, and make sure that it actually looks correct, right? So glancing at it like that, it looks correct, but we know we're off by 1 pixel for some reason. And it could be the renderer might actually be correct, and there could be some other thing going on here. So right down here, right, we have this. If this is not exactly 32 by 32, then we have a problem in some older code, right? So let's see what happens, right? So if we take this, oh, hold on. Take this like this, cut it, go File, New. Okay, no, it's 32 by 32, right? So this is exactly 32 by 32. Now, there's still some other things that could be happening here, though, right? So, okay, well, if that's 32 by 32, that's fine. But maybe if we put this kind of toe-to-toe with some other stuff, maybe we're going to find some other problems. So let's take this for a second, and let's just delete this out of here, and let's just open up our brush, make like a little black and white, like, kind of like thingamabobber here. We don't gotta be too perfect about it, right? We'll just kind of do some stuff here like this. Right? And then we can take this and, I don't know, give it a green background or something. It's not what I wanted. Anti-aliasing, where are you? Turn off. Okay, so take something like this, copy it, and then don't save. Go over here. Let's just start pasting that, making sure that everything lines up absolutely pixel perfectly, right? So maybe there's the possibility that something is off by a pixel. Like maybe maybe this is all shifted over, right? So maybe this is correct in size, but maybe if we try to do this, we're gonna find that, hey, everything's shifted over 1. So that lines up perfectly. That's what you're trying to render, but scaled the 512 square. Yeah, so I'm trying to render this 32 by 32 section, right? And the rendering seems like it's off by 1 pixel for some reason. So that all checks out, right? That checks out pixel perfect. So this thing right here, this thing is the actual original location where it was, and it looked good. But let's take this and paste this here, and let's give it like a red, right? So let's put a red here. Say, hey, this is the coordinate we are concerned about right here, this thing. And then let's kind of help you visualize what we're looking at here, right? So, and we'll upload it to Imgur as well, so you can get an idea of what's going on here. So this is off by 1 here. I think it's just because my my fragment chord calculation is off by 1. I don't think it's the actual rendering logic there. It's off by 1 pixel. And we remember that, oops, that this is not exactly 512 by 512. My bad. So let's just take this. And cut this. Okay, so it's off by 1, but this is the memory region we want to look at. So this red square, so this is the whole 512 by 512, and we want to look at this little. Why isn't it 512 by 512? Like, why is it off by a little bit? Yeah, I'm trying to upscale it. I'm trying to zoom in, right? I'm trying to zoom in. And I just arbitrarily chose, like, to zoom to 512 by 512. It didn't have to be 512 by 512. It could be anything that I wanted to zoom into. But I just wanted to zoom into it so I could see those individual pixels, right? Because in order to see those individual pixels, otherwise I would have to kind of open it up in a Paint program to look at it. I wanted to be able to verify it in... Oh, that's because, yeah, so let me show you why, so that thing, so let me show you that, so that's because, okay, let's just open it up. So, okay, so let's go over here, let's press U, let's go over here. So you're looking at this, so you see this? This is not 512 by 512. That's 512 by 512, right? So we were hiding some of it, right? So it'd be like if I screenshotted this, right? That's not 512 by 12. This is not 512 by 12. This is not 512 by 512. This is not 5 by 12. It's this, right? Now we have the 512 by 512. Yeah, you were lied to all this time, yeah. So the reason for that is just because, remember how we were talking about, Yeah, so I'll have to fix that later, but yeah. So that's what that is about. But yeah, when we look at the exact texture, when we look at the exact texture view, it looks like everything's in the correct spot, right? And so we kind of did this to like make absolutely sure, right? So we kind of pasted it. And if we look at this coordinate, right, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, no, this isn't 13, 13. I counted this wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 13, comma 12, right? Yeah, exactly. Yeah, unfortunately. So 13, comma 12. We can make a note of that right over here, right? So right here is... Let's zoom in here. So this is 13, comma, it says 13, comma 12. Right, 13, comma 12, right here. Let's get fancy here. Let's put some brackets on here. Eh. Okay, 13, comma 12. Okay, so that's 13, comma 12, so let's go look at, let's save this. Let's file and save as sanity check upload. I'm going to upload this to Imgur. So let's look at that. So where the heck am I getting that? So if we look at Tau Depot data, right? So we have the 512 by 512. We subdivide it into this cell here. This cell we subdivide into these cells, and then we're looking inside of this cell. And if we do all the math correctly, this 32 by 32 cell that's nested 3 deep, 1, 2, 3 deep, is actually resolves to these exact pixels over here, right? So, so that was what I was doing with the mapping code, right? Where I'm trying to zoom into this in the viewport. I'm trying to get some camera logic that zooms in on here, and we're kind of like off by 1 pixel for some reason. I don't know why, because all the math seems to check out, but something we're doing obviously is wrong. So let's close this and let's upload that to Imgur. Don't save. I'm gonna upload to Imgur. I saw something slightly political on Facebook that I wasn't sure if it was true or not, so I'm not going to put my screen up there, because political things are more dangerous than porn in terms of getting yourselves in trouble, if you really think about it, right? So, let's... desktop, delete me, sanity check, upload to Imgur. Okay. So now we have... Okay, so that's up there now. So, I mean, you can take a look at that if you want. I don't know if it's really going to give you much insight, but it could explain kind of what I'm doing here. I'm going to close Imgur. close that, and then update my list. I had a list of so what's the date right now? It is it's 2021-02-16, right? And the vid IID is 0136. Okay, cool. Okay. So this is cool. We refactored some stuff, but the thing that sucks is I still don't know why the math is wrong. I don't know what's wrong with the shader code. So here's this GPUView thing. We know that one thing we could probably fix is the fragment chord math is off by 1, right? So we take the height and we minus 1, right? So that makes sense, right? Because you want the last valid upper bound index. And then we want to minus the frag chord. Oh, hold on. So this height is in terms of this y needs to be minus. We need to minus 0.5 here. So we have a minus 0.5 here. We actually need to minus it here, right? We want to normalize this. We want to normalize this to a discrete pixel unit before we subtract it from here. Because this here is already discrete. This is already a discrete unit. These are already discrete units, so over here this is 0.5. That doesn't go there. It goes over here. Okay. Let's give that a roll. And the idea is that we're going to fix the off by 1 error on the y-axis. The off by 1 error on the y-axis. So but we're really not going to see that, though. We're really not going to, we can't really see that. Without the zooming in code, we're not going to see that, right? We can't really tell that I fixed anything. So let's go add the zooming in code back. So over here, let's put this back in. And then this this thing here that's temp, we're gonna comment it out. So, and then we're gonna give that another run. And you're gonna see that on the y-axis, the 1 pixel off on the y-axis is now fixed. And we still have other problems, but at least we solved one of the mysteries. Okay, yeah, so you can see this. Now on the axis here, oop, hold on. We still have something going on here that's not quite right. But over here, this looks like it's nicely snapped on the y-axis to exactly where it needs to be. So we're still off, but it's more symmetrical in how it's off, right? So let's take this. So let's close this. And if we zoom in, we can see what's going on here. So let's go zoom in here. Let's open up the sanity checks. Sanity check, whatever the heck. 005. And if we look at it here, we can see this is flat up against the beginning of the client area, right? It's just right up against there. We're no longer off by 1 on the Y. Okay, if we go down here, something is still going on over here. Oh, that's because we didn't fully open that, right? So this, we still got something going wrong here. Right, but it's symmetrical. So I need to stop. I need to remember to kind of like open it up more, because we don't know how bad it is yet until we try to stretch the window open. So hold on. So let's look at this for a second. Let's try this again. So go over here, press the U key, and then go 0 over here. Okay, so let's move. Let's try to open. Oh no, never mind. That was what we had. Okay. So yeah, this is completely symmetrical now. So we got rid of one problem, but still something's off. I don't know what's off though. It seems that when we're trying to print the whole texture, it seems correct. So I don't think it's our texel fetch. I don't think our texel fetch is incorrect. Maybe the canvas user view coordinate is incorrect. Maybe canvas user view. How are we calculating canvas user view, right? So let's kind of go up here and say, well, canvas user view, we take this fragment coordinate, and if the canvas user view is greater than 511 on the X or the Y, then we're out of bounds. Otherwise, we're good. I mean, that looks good. So this doesn't look like a problem. None of this looks like a problem. Unless, unless for some reason this resolution was wrong, but that can't be it, because we get a 512 by 512 square, and even if we didn't, we're very close, right? So, right, like that last image, right? We take a look at that last image we took. I'm pretty certain we're going to get exactly 512 by 512 if we try to select this all. But let's select it and see what we actually get. $512 by $512 exactly, right? So this is exactly 512 by 512. So I don't think the canvas user view location, I think that's fine. I think the texel fetch is fine. I think the data is in the exact correct location, right? Because we measured that out. We measured that out. We measured that out with right. We measured this out, and that checks out to be in exactly the right location. So these pixels are pixel perfect, exactly where they're supposed to be. It's just that when we zoom in, we're not snapping to exactly where we should be. So that just kind of leaves our mapping logic. So I thought we already tested the extreme rightmost coordinate, right? I thought we already wrote tests for that, and they already ran, and that was all working. And so fragment common code, if we look in here, right, so this is where the test code is now. Alright, we tried this like 511, 511 with this 416, 384, 447, 415, right? We tried that. Let's see if we can sample this. That's not going to be completely right because this is off by 1 pixel. But we at least can look at this pixel here and see what that is, I think. So this is 416. 416, cool. 416 and 447 then? 447. That's 447. That's 416, so that's correct. Now, we might be off by 1 pixel because of the bug we fixed. But we have 384 and 415, right? So what do you got here? 385, that's off by 1. And 416 off by 1. So I'm satisfied that the data is in the exact correct place. When we're not zooming in, it's rendering exactly how it should render. And so the question is, well, if that's the case, then why is it that when we try to do this remapping logic, it's not seeming to render it how we want to render it, right? It's like, hey, it's not rendering the last kind of pixel down here. I have no clue. I have no clue why that is, and it's kind of infuriating right now. I don't know. I don't know what's going on. I'm kind of lost. I have no clue why it's doing what it's doing. And it's like, I don't know if there's some type of obvious thing that I'm missing, right? Because we got these nice asserts to check our logic, right? So we got this 416, right? So we even took these we took this paired comment, right? Paired comment, GPUView asserts. So this is now, this comment here, right? So let's take this and rename this as fragcom asserts, right? Because it's in, well, actually, no, it's in fragcom, but it was originally GPUView asserts. Let's just keep it like this. Yeah, let's not change that. Yeah, so the asserts pass. The tests pass. The tests with the actual problem that we're trying to solve, we ran the tests, and even the tests work properly. So, I think maybe there's some type of fundamental mistake I'm making. Like, there's some type of fundamental assumption about how the renderer works that I'm missing. Or some extra transformation that I'm missing. And I don't know what that would be. We know that when we map it, we know that everything that's getting mapped seems to be off by 1, right? Like the... So the images, so if we look at this, let's look at that sanity check again. So there was something that looked wrong. And it should be in this sanity check as well. So let's look at the sanity check 5. That this right here, you notice this isn't completely square, right? So if we take a look at this, and copy this, and go File New, 33 by 33. Okay, if this is 33 by 33, and it's 1 extra pixel wide and tall, right? If it's 1 extra, it should be 32 by 32, but it's rendering as 33 by 33. So if this is 1 extra pixel, well, there's 16 of these all the way to here, right? And by the time that compounds, that's going to compound. So we got 16 of these blocks that are using 1 extra pixel. By the time we get all the way down here, we're missing a total of 16 pixels, right? So this would be like about 16 by 16. And so we don't see this whole thing because for some reason the math seems to compound and keep on losing more and more pixels. So the question is why? Why is that? I have no clue. I have no clue. I don't know why. But that's part of the key of what's going on here. I just don't know. That's part of the key. Yeah, that's part of the key. Whatever's going on, it has something to do with that. And the question is, where's the logic going wrong? Because it looks like we wrote our tests, and that worked out fine. Right, we wrote all these tests, and we're pretty sure. Just check the math. So how about we try to emulate... So yeah, so how do we check the math for this, right? So let's try to emulate getting these exact pixels, right? So let's try to get the exact... Well, this isn't just a pixel, is it, anymore? It's there's more stuff going on, right? Because we zoomed in. Yeah, just check the math. Yeah, I mean... Okay, yeah, yeah, I mean, that's basic, yeah, that's what we have to do. So simple, right? Just check the math. But yeah, if we can try to get this upper pixel here, if we can try to get this pixel, do some math to get this pixel, do some math to get this pixel, right? But now it's a pixel of a pixel, right? Because this red thing is just one pixel that we're zoomed into, right? And so this is a pixel of a pixel, this is a pixel of a pixel, this is a pixel of a pixel, that's a pixel of a pixel, right? So, so that's some craziness. Oh, there's some... I do not know the meme, so there's a meme, huh? Oh, god, yeah, somebody joking? I mean, but it is... yeah, it is kind of like a... If we could run this, right, so we have a ability to test the shader code pixel per pixel if we really want to on the CPU side. Like, we have that ability. But, I'd really not want to because now... yeah, meh. So I think part of the key here, you're trying to map pixels here to here. So we want to, okay, hold on, so. Yeah, okay. Chat says just buy a house, yeah. Yeah, banks are messed up, man, right? So, right, they do fractional reserve banking. So they get to, like, basically loan out money that does not exist, right? Which basically creates a musical chair, right? You can't... someone's going to not be able to pay back that loan because they're using fractional reserve banking, right? So they loan out more money than exists, right? So they loan out money they don't have. You get a house. Let's say you pay it 90% off, but then you lose that game of musical chairs because there's really not that much money in circulation. So somebody must default on their loans. So you pay off 90% of your property, but you miss a payment, then the bank takes the whole house, right? So they take your property when they loaned you money that didn't even exist, which is, like, crazy. So it's like somebody... The way everything's kind of organized, I think that somebody must be homeless, right? It's like a life is this competition, and it's like the bottom tier is always going to end up homeless because of the way society is structured, right? So that's the That's the, I guess, the more liberal part of me talking, right? Or I don't know if that's also a conservative belief as well, but I would say origin of the meme. Okay, let's check that out.
If you're homeless, just buy a house.
Ah, I see. Well, we'll put that in the archive. Okay, homelessness solved. Got it. Yep. Okay. Okay, so here's what we're gonna do. We're gonna say, hey, this 0, 0. So the global coordinate is 0, 0 here. It maps to this first pixel, right? Then over here, this should map to here. So we want to test out, I'm gonna place some, actually, let's not use this color. But no, we can actually just check the math, right? So I'm gonna place some gray pixels where we want to test. Right? Now, we don't want to test how this is off by 1. We actually want it to just be correct, right? So we want to test here and here. We want to test here and here. Okay, so that's a big deal here, right? That's a lot of stuff, right? That's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Like 25 more tests. But I think that's kind of going to be the key to figuring this out. So here's what we're going to do. We're going to screenshot this, right? So we have this grid overlay. I think this grid overlay is kind of helpful. So let's kind of screenshot this, so you have something to work with. Okay. And then let's open that up. So file open. Okay. Let's image resize and by percentage and make it like a little bit bigger. Well, I mean, that's actually a pretty good size right there, right? Because we don't have to, it's not overflowing. Well, let's just stick with that. So let's take this, it's called something to work with. Let's paste that up on Imgur really quick. Okay, so that's on Imgur. So we can look at that, and we can start writing test cases for that. Because I think we can actually, yeah, we can actually try to verify that, right? Because we see these things that are off by 1. So we can start to try to look at that and see what's going on there. So I think that's what we're going to do. And we're also going to make a little diagram, right? So we have these tests. So let's just write some more tests. Also, let's kind of keep that diagram open. So let's keep it open so that we can look at it. Come on, come on. Okay. So I want to be able to look at this while I kind of write the code, so that I can figure out what the heck is going on here. Also, users in chat. Okay. So let's 1, 2, 3, 4, 5. So let's go through it in scanline order, right? So let's do the exact scanline order of this. So let's actually draw out a diagram, right? So the diagram is, we have kind of like this. I don't know how we want to draw this. Okay, so 17, 18, 19, and 20 are the test indexes. So we want this to be like test index 21, 22, and 23, right? So let's label them by the test index number and make like a little schematic diagram, right? So let's make a schematic diagram of what we're trying to expect here. And let's not make this so big here. Let's kind of condense it a little bit. Okay, let's zoom in here. So we're just gonna we're making a schematic of, so I might want to make a note here, right? So, you know, at vid IID, and we're currently on, let me move this over so I can see it. Okay. So the video number we're on is, you know, 0136. And the time is 4 hours, 35 minutes. And 42 seconds, because we want to be cool. Transcribing from something to work with .png, right? So we're transcribing from this something to work with .png. We're kind of creating a schematic diagram of the test cases that we want to get working here, right? So we got these numbers here. Let's kind of steal those and put them down here. And that looks pretty square, right? So 24, 25, 26, 27, and 28. So these numbers are the test cases, right? So this is test case 20. So this is test case number 21, right? So we're going to hard code the test cases in there to make this a little bit easier to figure out what the heck's going on, right? And so the little brackets are the test cases, and this bracket represents the test case, but it also represents the actual pixel that we're trying to target for that test case. So now let's take this diagram here and let's cut paste it, and that looks pretty good. That looks good. So now we want to say 28, 29, 30, 31, 32, 33, 34, 35, and 36. Okay. Let's make sure that's correct. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay, cool. So we got all these test cases. And we know that this is supposedly this should be 32 pixels right here. 32 pixels wide right here is what we're expecting. Hold on. No. Well, yes. Yes, because it's 16 pixels and 16 pixels, right? So, yes, 32 pixels. It's rendered as 32 pixels, right? Because if we take So we take 512, right? We take 512, and we divide by, I think that's divided by 16, because there's 16 blocks total. 32, right? So 32. Now, because we have 16 blocks, remember? So if we go into paint.net really quick. If we go into paint.net and we say sanity check, right? So this has 16 by 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So if we take 512, divide it by 16, then each one of these little sections of pixels, these 4 pixels should be rendered as 16 pixels, right? So 1 pixel takes up 16 pixels when we zoom in like this, right? So we want to make sure that we know that, so that we can make sure this math is pixel perfect, right? So right now the math seems to be off by 1, and now we can try to fix that. So let's... also, we're going to need to put this inside of comments. So we're going to take this diagram and throw it into a comment. Okay. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 test cases. So let's do it square by square, right? Square by square. Let's just do top left. And hold on. Oh, because this is, we can't center this, so we gotta do top left like that. So this is top left. This is top right. Then we can kind of steal this. We're gonna cluster the tests in bottom left, bottom right. We're gonna cluster the tests in kind of sets of 4 here. So we can take this. Let's steal this like little diagram here. Don't know what I'm doing. Okay. And we can say the test index for this is going to be 21, 22. Oh, hold on. If that's the way we want to roll, then we're gonna have to change these numbers, right? So if that's how we want to do it, if that's how we want to partition it out, that's fine. But we're gonna have to change this to 21, 22, 23, and 24, right? We're gonna have to renumber these. This is gonna have to be 25, 26, 27, 28, 29, 30, 31, and 32, 32, 33. Okay, so we screwed something up here. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, oh, 33, 34, 35, 36. Okay, we can do that. That's not a problem. But we gotta make sure we're consistent here. So, okay, top left tests are, the test indexes are 21, 22, 23, and 24. And it's just that we don't want too many tests clustered together here, right? Because then it kind of gets kind of hard to keep track of what's going on here. Okay. So, we have this. Let's get designy. Okay, so now we can steal kind of numbers here. Okay, so with these numbers, what numbers do we need? Well, first of all, let's not worry about what the actual numbers are for some of these things. Let's just zero this all out here. We know that we're going to map to 0 to 511, right? So you have a point somewhere on a 0 to 511 inclusive rectangle. And then we're mapping onto... Oh, we're mapping onto this, right? Because it's this thing. This is the thing, right? Right, we already calculated these. We already decided that this was the correct rectangle, right? So that's good. That's good as it is. We don't know what this needs to be yet, right? We don't know what this needs to be yet. So, how about, let's, define... Technically, that's result. I want like a little thing that kind of. Okay. So the parts that we need to fill out, I'm going to fill them out like this, right? So we have this X and Y that we need to fill out. And then over here we have this that we need to fill out, right? So we don't know what these need to be yet. We could say like this is define. We can make Y's here. We can make little faces. Right. So we need to fill out these. We need to fill out this. We need to fill out that. We don't know what it's supposed to be yet. Fill out these with correct vowels. Right, so we want to take these, and where we find them, we just want to fill them out with the correct values. Right, so these are just placeholders until we figure out what the heck we're doing. And now what we should be able to do is we should be able to take this, and we should be able to just paste and change some of these numbers here, right? So now we have this graphic here, right? So let's take this graphic, and this should be the second thing. So this is going to be the top right, and this is, you know, 25, 26, 27, 28. Okay. Let's copy this and paste it again. Now we're on this thing here, right? So let's steal this. Okay. And then down here, we're going to just go whoop, over here, and then we're going to go bottom left. Okay, and then we have 29. We got 30. We got 31. We got 32, right? Okay. We're going to steal this one more time. Alright, the idea is we want to break this up into manageable pieces so that we know what data we're looking at, right? Because this is getting kind of long. Okay, so 33, 34, 35, 36, and this is the bottom right. And we can name these 33, 34, 35, 35, and 36. So all these numbers should line up, 33, right? All these line up in order. All these numbers line up in order here. Okay. All these numbers line up in order, right? So if we click these, we can see them kind of lined up there. And then down here, this is over here. Okay, excellent. So now everything's kind of stubbed in. And how many more tests have we added? We have added 16 more tests, right? So we have 4, 4, 4, and 4. 4 times 4 is 16. So we want to go here. The number of tests, 21 plus 16. Let's not trust ourselves to be able to do math. Let's go find a calculator. 21 plus 16. You know, if we could be trusted to do math correctly, we wouldn't be in this situation in the first place, right? So that's my logic there. So the number of tests is 37. 37 tests. Okay, cool. So now that we have these extra tests, we're going to expect them to fail right now, right? Because we haven't really added the numbers in yet. That's fine. We'll close this, right? We see that the stuff is off by 1. That's fine. We're done looking at that for now, right? We've transcribed it into an ASCII diagram. So let's try to run this, and let's see if it fails on the first test that we stubbed in. So we're expecting it to fail on 21, test index 21. So when it fails, we're going to expect it to say test index equals 21. Or signify that the test index is 21 in some way. Yeah, so the test index is 21 right here. Now these tests we have not filled out yet, so that's obvious that it would fail. But let's try to fix it now, right? So let's, okay. Are we ready for this, though? Yeah, I'm ready. Okay. Whew, boy. Okay, so the first thing is... This is 0, 0, right? This is 0, 0. And over here, that's also going to end up as 0, 0, right? So we're not expecting any displacement. Okay, simple. Okay, well, what about this? Well, we still have a 0 on the y, right? So we can fill this out. On the y, we still have a 0. That's easy. Okay, now what about the x, though? Well, on the x, we're expecting that this is the last pixel of something that we're displaying as 16 pixels wide, right? We're displaying 1 pixel as 16 pixels wide, so therefore, we'd expect the last pixel index to be 15. Hold on. The last pixel index here is 15. When we map it. Okay. And... what is this, though? Hold on. Uh-huh. Oh, so I'm screwing up here. We're expecting this to be... this is the on-screen coordinate, right? God, my neck hurts. What are we trying to figure out here? We're looking at a fragment, we're looking at a location on the texture, and we're trying to figure out where it maps to on screen, right? Oh, you know what? So maybe we're doing things backwards. Like, okay, we can write the test for this, and the test will probably pass, but I think we're doing things backwards. We're going from... Maybe not. So I think what you might be doing wrong is we are going texture to screen/frag, but we should be going from screen/frag to texture. And I think that it's coincidentally mostly working because we've made the screen size we've made 512 by 512, and the texture is also 512 by 512. So the math is like mostly working out, but we're not mapping in the right direction. I don't think we're mapping in the right direction. I think we're going from so this is actually, no, this is screen. No, we're mapping. No, we're doing it correctly. Mapping in direction. So we're mapping in direction screen to texture. Right, that's screen/fragment to texture. That's it. No, we're doing it correctly. Never mind. Okay. So on the screen, if we're at like 0, 0 on the screen, then we want it to be this lower bound here, right? So this lower bound here, lower bound x, lower bound y, right? Or actually, no, these are both the lower bounds here, right? So it's just these two things, right? That's what we're expecting. Okay. So if it's this now, it's going to be lower bound and it's still going to be the lower bound on the y, but, and this is going to be a, on the screen we're rendering it as 16 by 16, so if we go to 15 on the x, right, 15 on the x should get over here, right, it's the last pixel, and so instead of 416 on the x, we're going to expect like 416 plus 15. That's going to be 431. Okay, so before we even try to go any further than this, let's see if we can even pass these two tests we wrote, or if we're just like, we completely don't know what we're doing, right? So before we even try to get any more complicated with kind of drafting this all out, let's see if we can even do this, right? Because I don't know if... So we want to see if we can crash on test number 23 rather than 21 or 22. Or maybe get past 21 and get stuck at 22. So 21 we got stuck on. So the x is... So 431 and 384. But instead we got 416. So I would say it looks like it's kind of... that doesn't look right to me. Test number 22. SX is 15. And the expected... The output is 416 still. So we change this to 15, but we're still getting, you know, this. We're still getting 416. That doesn't look right. So I think the math is... So I think we found... So I think this test is written correctly. And we're just doing something wrong. Because our mapping logic says... Our mapping logic is wrong, I think. Okay, it would be nice if we could try something where we're a little bit more normalized with, like, more regular numbers. Right? So instead of, like, instead of 500, we have, like, a 300. And then we divide things into 100s. Let's say a 300 by 300, we're divide things into 100s. So... I'm going to steal this diagram here. Oh, boy. Now, let's just bite the bullet here. We're going to copy this. We're going to paste it over here. The time is... 5 hours and about 32 minutes, because we like even numbers, or powers of 2. Try our actual scenario with easy to comprehend numbers first. So let's try to do this with like easy to comprehend numbers, right? So so we want something like canvas size equals, you know, 300 by 300 pixels, right? So something that we can easily do this. And then, it's only slightly off, though, so... I want to try... Actually, let's try 900 by 900. So we have a little bit... We have more granularity. 900 by 900 is bigger than 512 by 512. So we got more granularity in case, like, the errors don't show up until we get higher numbers, right? Because maybe things get automatically truncated. We don't see it until we use fine-grained numbers. And then what we're going to do is we're going to say that, you know... we could just use multiples of 50, right? So each tile could be 50 by 50, right? We could call this right here, we could call this, you know, 100. And then we could make this 50. Right? To keep the math kind of simple. And we're going to look at the first tile still, right? So, this can be 21, 22, 25. We can keep these numbers here. And... we're just gonna... we're gonna steal this first, I guess. because these numbers are going to stay the same. We're going to change these to X's and Y's, because we don't know what's going on yet. Oop. Okay. And we don't know what's going on over here yet. But we know that this thing here so this mapping here, we can say that this is a 100 by 100, right? So let's just say that inside of the 900, so if we have 900, right, we have 100, this is 100 wide, 200 wide, 300. There's our 300. We have 1, 2, 3. 1, 2, 3. 7, 8, 9. Okay. And so we want to create like a 100 by 100 that's kind of like right here, right? So this, right, so this is right here. So when we're looking at this diagram, it is coming from, this is where it's coming from. This whole thing is this, right? It's the whole thing right here. Okay. And so this is a 100 by 100. It's mapped inside of here. So this is the 100s. So 0 to... Actually, no, this is the 0 to 100. Okay, so this is 0. This starts at 100, 200, 300, and 400. So this starts at the 400, right? So... So it's an inclusive rectangle, right? So this one is 0 to 99, 100 to 199, 200 to 299, 300 to 399, 400 to 499, right? So that's what's going on here. Okay, so now that we know the range, let's just keep everything completely symmetrical, right? So let's not worry about... Let's just say that we're right in the center. So the lower bound on the X and Y is the same, right? So we got lower bound here, and then we got the upper bound, and this is an inclusive lower and upper bound, right? So throw that in there like that. And the screen chord is... This is the screen size. So, screen size. Okay. And then... mapping to... mapping to a 100 by 100 block. Sure. Sure. Okay. So we got that. We got this. So what is this? Is this correct? No, because we don't want... We're saying this is 900 by 900, right? So to get 900, we're going to need to make this 899, right? So 899 and 899. Yep. So that's the basic kind of layout for what these tests are going to look like. So we're going to steal this and paste it down 3 more times. And then we're going to take these respective diagrams, so top right, and we're going to paste it, the top right over here, right? So we're going to paste that top right over here. And then the bottom left, we're going to paste that as well. And then the bottom right, we're going to paste that as well. Now the thing is that we should probably just give this a different coloring so that we don't want to accidentally edit one piece of code when we mean to edit the other code. So let's just give it some color coding. So top left, top right, bottom left, and bottom right. So I try not to get too fancy with coloring, but in this case, we just want to make absolutely sure we don't confuse it with this, right? And so we might as well say, well, if that's green, let's color this blue, right? So this will be blue, or maybe it's like orange because it's like the harder section. It's like the harder section to figure out. So maybe we want to give it like a little more kind of like a color that kind of more conveys trouble, right? So orange is a more cautious color than blue. Okay, so now let's just color code this. Oops. Color code this all. Okay, cool. So now we have these tests. Here's this diagram, right? This diagram is nice. This isn't filled out yet, right? But these numbers are correct, right? So to 36, this is 36. However, this diagram here is not correct anymore, right? So this diagram here needs to... Let's color code this orange, right? So this is the orange kind of diagram. So we'll color code it the same as the stuff down here, so we know what it correlates to. And then we can do the same over here, right? So we can take this and we can just say, hey, you know what? This diagram here, this stuff over here is going to be green, right? So we can say, try to put that in here like that. And unfortunately, we're kind of like running out of room here if we do that. So what we could do is we could collapse this a bit. So we could just say, you know, 1, 2, and 3. And then 1, 2... Oh. And then we could move this over so it's still centered there. Okay, now we have enough room. Okay. So yeah, so we want to do this first set of tests here. And then we want to do this second set of tests with the actual use case. With the weirder numbers, right? So we left off at 36, so this needs to be 37, right? This needs to be 38. This needs to be 39. This needs to be 40. Okay. Then after this needs to be 41. This needs to be 42. This needs to be 43. And this needs to be 44. So this just kind of sucks, but we're just going to have to go through this. 45, 46, 47, 48. It's going to be 49. This will be our 50th test case, our 51st test case, and then our 52nd test case. So that's what we got here. Let's make sure that looks correct. So down here, the last test case for this is 36, so that means that this is 37. Let's just count really quick. 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. Okay, so that all checks out. So let's take this and paste it over, right? So these numbers are not correct, so let's paste that there. And then let's take this and paste this copy, right? So these are these mini diagrams to know what test case we're looking at. And the bottom right. And also, if anyone wants a technical demo of what's going on, if you want to see like graphics and stuff, because I see somebody popped in, I'll show you. Just ask me. I'll show you what's up. So let's kind of check who's in here. Yeah. Anyways, let's keep on going here, trying to write these tests. So we have one more thing we got to fix here, right? So the test index is not 21, right? It's 37, 38, whatever, right? So 37, 38, 39, and 40. Okay. These test cases, this is going to be 41, 42, 43, and 44. Right? So these are the test indexes here. 41, 42, 43, and 44, right? So test cases 45, 46, 47, and 48. These are these test cases here, right? Which correspond to these physical pixel locations here. Okay, so now the last test cases 49, 50, 51, and 52. Okay. And that's for this. Okay, cool. So we've stubbed in like all the test cases. Let's make sure that this is defined properly or in the proper location. We could... Let's move this up a little bit further. Let's just throw this up at the very top of here. It's a multi-line comment. Let's just throw this here. I don't know if it's the best place to define this. Now, is that lined up correctly, or is that off by 1? Hold on, so... Well, this is off by 1, but besides that, that's actually in the correct location. So we go all the way up to where we defined it. Oops, too far. Right there, bam, right there. Lined up, nice. Okay. So this first set, this green set, is we're trying to use kind of more rounded numbers. Oh, what time is it? 2, whatever the heck. Also, yeah, if anyone wants some technical demos, I'm going to throw my technical demos into the chat really quick, in case somebody wants to look at that, because I see 4 people. Okay. So... we want to try to get this first pixel here, right? So we had like a little image, right? Let's go look at that really quick. So let's move this over here for a second. So this is what we're trying to figure out, right? See these gray pixels? We're trying to figure out where those are when we're doing our remapping logic. And this is at an actual screenshot, right? And we're trying to, in the green section, we're not doing the actual use case, right? This orange section down here is where we're actually going to do the actual numbers, right? Like this is 32 and this is 16. But those numbers create some really hard to work with logic, right? Where these numbers are just really weird, right? 384, 447, 415. So we want to try to mimic that scenario, but use numbers that are a little bit easier to work with first, right? Because if we can't get this test code to pass this green section, then we're never going to get the orange section to pass, right? So that's kind of the goal. So right here, we're trying to look at 0, 0, right? So we're starting off on the screen with the fragment coordinate at 0, 0. So the fragment coordinate is at 0, 0, and the screen size is a 900 by 900, right? So the screen goes from 0, 0 to 899, so it's a 900 by 900 screen. And then we want to remap to this 400 by 499, and the 400 by 499 is this cell here, this 100 by 100 cell, right? So this is, you know, 900 by 900, and we want to remap to a subsection in there, right? Okay, so if we do this correctly, and we're looking at this, then we're going to expect to be at exactly 400 and 400, right? We're going to expect to be at the lower bound, right? Pretty sure. And this is 50 wide here. Okay, cool. So now let's try, if we go to 50 on the X, or if not 50 on the X, but 49 on the X, right, to get the last pixel over here, if we're doing cells that are kind of 50, right, so we want to get over that, we want to get this 22 here, right, or this 22 here, then we have 49, and the Y is still going to be 0, so we're not going to change the Y, and if that happens, then, since the Y doesn't change, this is still 400. However, this right here should now be 449, right? So the math is kind of, we want the math just to work out much simpler, right? So it's still not as nice as, you know, an even 50 here, but that's because it's an inclusive rectangle, so, you know, 0 to 49 is an even 50 rectangle. So the math still is kind of a little weird, but it's better than where we were. So we know that we have 16 tests here, 4 times 4, so 16 more tests. So we're going to go up to where we declared how many tests we have, number of tests 37, and we're going to just say, okay, well, what's 37 plus, you know, 16 more? Check that in a calculator, because we obviously can't be trusted to do this correctly, because if we could be trusted to do something this simple correctly, we wouldn't be writing test code in the first place. It would just work, right? So, okay, so that's 53 tests total. And so what we're going to hope for here is we're going to hope that the test index that we crash on is not 21, it's not 22. We're going to hope that test index 23 is where we start to crash, right? If we crash on one of these, then we have a serious problem, but at least we have some kind of easy to comprehend numbers as we're trying to fix the problem. So let's give this a shot and kind of see what happens. So this is more test code in debugging than I thought for this simple formula that I was writing, but oh well, happens. That is test index 22. What's going on here? So here's what we're getting out. We're getting 405 out and 400, right? Is that sensible? Is that sensible? Does that make sense? Don't think so. Well, let's hold on here. We're expecting 449 and we're getting 405. So we're getting something that's rendering as only getting tired. I feel like I just want to go to bed. So if we want that to remap, how do we know that it's supposed to remap there? Yeah, I'm tired. I think I obviously don't completely understand the problem, I think. Like, maybe my remapping code is correct, maybe it's not. Maybe I'm just using the remapping code in the wrong way. And this has kind of brought to light what's going on. Now, we could really easily fix this if we just make the rectangular region for this. This is 100. So we're saying that pixel is in this 100, 100 area. We want it to map to the center because we said so here. But it's only 5 because... So, are we mapping a... When we originally did this, were we mapping a bigger to a smaller or a smaller to a bigger? We were taking... bigger to a smaller or a smaller to bigger? I don't know. I think my brain's tired. I think there is more to do, but I'm tired. I'm getting tired. So if we want the mappings we're talking about, then if we want that to be 449, what do we have to do? Well, that's 100, that's 900. Yeah, I'm tired. I'm getting tired. I'm trying to think about what to do here, but I just can't. I can't figure it out. I think my brain's tired. So we can try to maybe we want to try for a little bit more, but it's just a simple remapping problem. I don't know why I'm so, like... because I've been at this for, you know, 9, 10, 11, 12, 13, 14 hours. That might be why I'm kind of not knowing what I'm doing. So this cell here, are we assuming this is... What's the origin of this? We're expecting that this origin is at, like, 0, 0. And we're trying to map it into here. But if we want this to map... So the screen size is 900 by 900. And we want to move on the screen. And we want to render... We want to paste... We want to map the first fragment coordinate to this 100 by 100 block inside of a 900, 900, right? So we want to so yeah, the screen size is 900 by 900. So this is the screen size right here. This is the 900 by 900 screen size. And we're trying to render this kind of layout in the center. Well, if that were in the center, if we're really trying to render that in the center, then we would have to go with, like, or would we have this backwards, right? So this is a... No, this is... So this... Okay, hold on. So this and this, these are the same coordinate space, right? They're the same coordinate space. It's just that one is a subsection of the other, right? Actually, I don't think that necessarily has to be the case, right? It's, we're remapping one rectangle to another. Okay. We're trying to loop through every single fragment coordinate and see what data points are underneath it. Huh. I think it's bedtime. Yeah. I think it's bedtime. I can't really think about what needs to be done here. The test will fail there, so we'll figure that out. So hold on, let's just write this out. So we want to sample each pixel of the 900 by 900 screen and figure out what pixel of the 400 or of the 100 by 100 texture memory subsection at 400 comma 400 to 499 499. Okay, so we want to sample each pixel of the 900 by 900 screen and figure out what pixel of the 100 by 100 texture memory subsection at 400 comma 99 to render at that pixel coordinate. Right? That's the summary of like what we're trying to do, right? So right here is what we're trying to do. Yeah, so that's what we're trying to do. I don't know. I don't know how we're going to do it, but we know that's kind of what we want to do. That's what we're trying to do. Because we're trying to create a zoom-in effect, right? So, we're trying to create a zoom-in effect, right? So, trying... Yeah, so after looking at this, I think that that there's some type of, yeah, we just don't completely understand the math like we thought we did, I think. So basically, this thing covers 400, 400, 499, 499 in terms of where it's like located in texture memory. And we want to stretch it across the screen, right? So we want to take this, want to iterate through all these pixels and stretch it across the screen, right? And if we do that, then, you know, if we take 900, right, that's the whole screen. And we divide by 2. Then this will stretch to 450, right? This whole thing stretches to 450. So this is... So it said 100 and... So I don't know where we got these measurements, right? Because it looks like it stretches to 450. Or this is actually... This is the texture width, right? So this is the texture width. But in terms of on screen, it's more like 450 and then So we took 900 and we divided by 2. So this is the width that it's going to stretch the screen, right? So that means that this is 450 here. And that means that this is 900. Right? 800, 900. So this right here is the right? And we actually render it. This is actually what it's going to map to, right? So we're taking this thing, and maybe in the texture memory, you know, it's a 100 by 100 block, right? So it's this 100 by 100 block in texture memory, but it's going to stretch to be like 900 by 900, right? Okay. And if that's the case, then if we want to get this 20-second thing here, then we need to stretch all the way to... There could be multiple pixels that would cover that, right? There's multiple pixels that are going to cover that. Right? Because we're mapping from... Yeah, there's multiple pixels that could cover this. So we want the last possible pixel that could cover this. So we're thinking that it's 450, right? So the last pixel would be 499. So we're thinking that this should be like 499 on the X. And that if we did that... And this is a 100 by 100. So we're thinking that if this is 499 in the X, that it's going to map to here on the texture memory. And that position should be... This is 449, right? Because 449 is... right? Like, if this is on the texture like this, and this is 50 wide, right? The last pixel, right, it's 0 to 49, right? So this is where we got this 49, but it starts out at in the 400. So, okay, so I think that that'll actually work, and we'll fail on test number 23 now. So I think that I understand the problem, and I think that I understand the problem, and we can get this working, but it also means that maybe the renderer code isn't written correctly because we don't understand what we're doing. Well, obviously the render, we don't understand what we're doing, but the test code is kind of helping us comprehend what's going on here. So we got 449, but it's saying 454. So we're off by a little bit. Okay. We said 449, it says 454. So we did 499. And why did we choose 499, right? 499 we chose because is that correct? If it's 900 by 900, if it's 900 by 900, 900 divided by 2. God damn it. Give me some actual math if I... Okay, so 900 divided by 2 is 450. Okay. So I don't know why we did this, because it's not that. 450, the midline 450. So 450 minus 1 is 449, right? Isn't that what we did? 449? Oh, we did 499 when we meant to do 449. Okay, let's... And then over here... This is 400 to... This should texture map to... Is that just coincidental? Or is that how it's supposed to be? So we got 400. So this starts at 400 and the last is 499. So 400 to 450, 450, 449, the last pixel. Okay, so I think that math is actually correct, but that just doesn't... That looks weird. That doesn't look quite correct, but okay. Let's see what happens if it fails on test number 22 or if it gets past test 22. So now this is I don't quite know what my code does. And as I write my tests and they fail and I'm trying to rewrite it. So now we're at test 23. So, okay. Okay. So that is weird as heck. So maybe this is just coincidental, right? That is just weird. Okay. So if we're going down here, right? So now we're going to move on the we're not going to move on the X, but we're going to move on the Y, right? So it's we're going to do 0 and this is going to be 449 now. And that means that these numbers should be just inverted, right? So it should be a 400 and a 449. And then over here, if we do everything maxed out like this, then we're going to expect to be, well, using this higher number. Okay, let's see if we can get past that. So I think that makes sense. Okay, so test number 25. So we got past all these tests, now we got to do this, right? Okay. So this section here, right? We see this is kind of 449 is the highest thing here. Well, the adjacent thing right here, the adjacent thing is going to be 1 up, right? So when we're trying to look at this 29 here, sorry, if we're trying to look at this 25 here, it is adjacent to the 22. The 25 is adjacent to the 22. So we just want to take this data set here and paste this for a second. And this is the higher number, right? So this is the higher number. So we'll figure out what that is. We know that the lower number is not going to be 449. The lower number is going to be the next thing after. So it's going to be 500. Okay. And then we're trying to start out at so this is the origin here, so we're trying to go over on the X. And when we go over on the X, we're going by we're trying to go all the way over on the screen, right? And the screen is 900 by 900. Okay. so the last thing here, if the viewport is 900 by 900, and we're trying to look at the last pixel of this, then we want to be looking at 899, right? 899? However, on the X for this, we're still at zeros, right? We're still at zeros on the X. Or no, on the Y's, we're at 0. Oh, crap. Sorry, that's still correct. We're looking at the wrong thing. So over here, this is the next block. So 25 and 26, we just translate on the X, right? So 22, 449. 449 and 0 is going to become 500. And 0. 500 and 0 because we're still at that top, right? 25 is still up at that top. This is 500 and 0. Okay. Then over at 26 here, we're still 0 on the Y, right? So this is still 0 on the Y. But now we're at like 899 here. 899 all the way over. Okay. Then down here, if we go down, we're at those 449s. Down here is the 449. So this thing here on the Y would be 449 here. This is 449 on the Y. And then on the X, it's going to be that 500, right? It's going to be that 500, okay, just like that. And then we want to move over. We want to go over on the X, so this becomes an 899. Okay, this is still 449. Okay. And then we're trying to map to over on the... We're still in this, like, this is this 100 by 100 thing. And so we're trying to map to the texture 1 pixel over. And we're trying to map to the pixel 1 pixel over, then... Right, we had 400, 400. But now we're going to expect to be at... We only moved over 1 on the X. We didn't move on the Y. So we're expecting 1 pixel over on this texture. So that would mean... Right, this is a 100 by 100. Stretch width, texture width. So we're sampling from, you know, we should be sampling from 401, 400, right? And then this 899 gets us all the way at the end, right? So the last thing on the end, we're going all the way to the end. The last thing is 499. So that's what it would be. And then this 0 here, well, 0 maps to 400. Right, 0 maps to 400. That's what we've seen earlier. So no reason to think that would change. Okay. 500 is the thing directly after 400, so that's why we have this 401 here. And 449 here is 449 in the X. 449, this is Y. So the 449s should map to 449 according to what this says, so that shouldn't change anything, it's just, yeah. It's just 449 and 449. Then 899. We already decided that 899 maps to 499, right? That's not correct. No, yeah, 499 because it's a 100 by 100 block. That's the last pixel, right? This is the last pixel of the. This is the last fragment coordinate, and the last texture coordinate is 99, right? Because it's 499. Okay, yeah. So I think that's correct for this next section. So let's give that a run and see if we can get through here a little bit further. Let's try to see if we can get all the green stuff done. And then we'll try more stuff. I don't know. So let's see what we figured out. Let's see where we are. So test number 25. What did we fail on here? 401 and 400. We got 455 and 400. So it's expecting for the X to have 455. Does that make sense? Well, maybe. So this 401 is coming from this 500, right? And 500, where is that coming from? We wanted to go 1 pixel over, right? To hit the next thing. So you see 449 creates 449 here, right? 449 on the X ends up mapping to 449 here. And so the logic is that if 449 maps to 449 here, then the assumption was, okay, well, if we just crank it up by 1, right? So if we crank it up by 1 to get 500, they're expecting 401, but it's not a one-to-one mapping, though, is it? Because why is it not a one-to-one mapping? So if we're going across this big thing here, so we have more units here. We have 900 units here, and we have 100 units here. So if we change by 900 here, we only change by 100 here, right? So the delta here is always larger than the delta here. Okay. So 25. Taking that into account and realizing the delta change here is always going to be greater than the delta change over here. But we changed 449 gets us 449. So if we change by 1 here, we're expecting less of a change over here. So 449 gave us 449. The next thing would be 450, right? Okay, hold on. Since when do I think that 500 is the next thing after 4... Since when do I think the next thing after 449 is 500? That makes no sense. So we're trying to get this 25th thing here, right? And... there's multiple pixels. Because of this, we have multiple pixels that will sample from the same texture coordinate over here, right? Because this is a larger region and this is a smaller region, right? So there's going to be some convergence. Okay. And test number 25 is failing me. We got 401 and 400. That's what we're expecting. We get 455 and whatever. Okay, well this is... if you want the first pixel on the next half, and this is 100, then this is 0 to 49, so that would be 50. But we're not doing that, we're looking at the mapping of here. So 400 divided by, if we do like 900 divided by 2 for a second. God damn it. 900 divided by 2. Come on. Google. Give me math. Don't give me these stupid whatever the heck's. So that's a 450, right? So that would be 449. So then why do I have this? And why is this 449? We want to be on the other side of 450, right? Want to be on the other side, so 449 is the last of here. So if we want to be at the next, we want this to be 450. So 449, 450. And that'll net us being able to look at so we're from the middle, 0 to 49, and then 50 to 99. So we'll take 50 and 450, right? So this should be 450, right? Okay, this is getting way too coincidental, where this 449 matches with this 449. And then we have 0 mapping to... 0 we already know that 0 maps to 400. Okay, so let's try that. See if we can get 25 to at least pass, right? So... can we at least get test number 25 to pass? I don't know. I think that maybe we need to use even smaller numbers, maybe. I think we need even smaller numbers to figure out what we're doing. But I can't tell if my mapping logic is wrong, or I just don't understand what I'm doing. I obviously thought I understood what I was doing, but I don't understand what I'm doing. So all bets are off, right? Until we understand what we're doing here. Right? We thought it was kind of simple. We thought it was just mapping one rectangle onto another. We have a point that's some percentage somewhere here, and then we map it to somewhere else. But there's something missing. That... Yeah. So what's the simplest case we could do? So obviously, we tried to make it simple. But we need to make it simpler. So we need to say... We need simpler test cases. We need a test case where everything is just different by 1, right? So we want to like write a test case where we have something like, you know, didn't we already do this? Isn't that what all this is about? Well, no, that's not quite it. That's very granular. No, this is this, right? So here's the input, and there's the output, right? And that all worked correctly. So we iterate over 0, 1, and 2, and so this is the input range. There's something within this input range, and then we map it onto here, right? But we're going from a lower, okay, so here's the problem though. We're going from a lower resolution to a higher resolution. And possibly the mapping works in that direction. But if we have a very large canvas with many pixels, and then we map to a smaller resolution, how is that supposed to work? And are we doing that correctly? And I think that's what's getting us. I think that's the part that's screwing us up. I think it's the down-resing that's kind of screwing us up. So... So could it be that mapping... The mapping is working in one direction, but not the other. So what I'm thinking is that mapping is... Yeah, I think that if we take something like this, and the input data set, right, we have a small range and we map it to a large range. Well, what if we map it from a large range down to a small range, right? So yeah, I think that's something we need to consider. Need to make sure that 1 can map from small range okay, 2 right? So these are the kind of 3 scenarios you can have, right? These are the 3 possible scenarios, and we need to make sure that we're doing this properly for all 3 of these scenarios. And I don't think we are, because we're seeing things that are kind of off by 1. We don't know exactly why it's off, but we're seeing kind of these artifacts in our shader code. It's either our math is either wrong, or we just don't understand the problem in how how it's supposed to behave, right? So we coded something and we might not completely understand how the range mapping works, right? So we need to make sure that we can map from a small range to a large range, right? So if you have a point on, say, somewhere within a 10 by 10 canvas, and we want to map it onto a 100 by 100, can we do that? Okay. And then number 2, can we take some point that's on a 100 by 100 canvas somewhere, and can we map it onto a smaller 10 by 10 somewhere correctly? And then lastly, okay, if we have something on a 50 by 50, can we map it somewhere else to that 50-50? Or, yeah, it's still a 50 by 50 block, but they're just they're just translated, right? So it's a 50 by 50 square in one place to another 50 by 50 square somewhere else. So the same block size, right? So this will just be translation. This is translation. This is stretch. This is squash. Yeah, this is stretch. This is squash, right? So let's make a note of what that is. So stretch, squash, and translate, right? So those are the kind of operations that we're trying to figure out here. Stretching, squashing, and translating are the kind of main transformations that could be happening here. Do you want to kind of... Yeah, stretch, squash, translate. Okay, cool. And... let's kind of make a note here. Let's just do hashtag error. Insert the above we're going to make that an error and just make sure that when we try to compile, it's going to give us that exact message so that we can know where we're going to start off later. So yeah, error, insert above 3 test cases below. So we're going to take these test cases above and we're going to insert them below, right? So so we're at video 136, and the time is 6 hours, 11 minutes, and let's do 42 seconds because we want to be cool. So yeah, let's figure this out. But for now, I think I'm done. I think that I've kind of figured out... I figured out that the mapping is not exactly what I was expecting. And I have to... Let's copy this. Yeah, I gotta figure out what I'm doing. I don't know what I'm doing here. So, yeah, I'm done, I think, yeah. For now. So let me think about what is going on before I stop. I gotta think about what's going on here, right? So we're trying to do like this range mapping logic to like stretch, to do like coordinate sampling to properly stretch a texture onto the screen. And we've encountered some problems because we don't we think that maybe we either don't understand exactly how that logic works, or alternatively, our math is wrong. Our math for the function that's doing that remapping is wrong. But it could just be that we just don't understand how the logic works, right? Like, we're not correctly conceptualizing the remapping for whatever reason. I don't know why, because I mean, in the render view, we're getting really close. So it's like, it feels like we have a handle on it, but then when we try it, it's like it just blows up in our face. So yeah, I'm out of here. Yeah, I give up. Good night. So let's look at this. This was 68, right? So 68. We're looking at GPUView code, trying to figure out what we're doing. We've done all the push-ups for Monday. We're gonna stop streaming, go to bed. Good night.